older PPTs or that PDF file you shared with me.
Okay.
Yes, I'll assist.
Okay. Because they are all handwritten. That's what. Material.
No, it's okay, sir. No.
Yeah. Because my present research scholars are there at their homes because of this pandemic.
No problem,
they are
sir.
not in campus. They are not in the department or campus. Yeah.
Your views and experience matters, sir.
Yeah.
All
Of
are eager
course.
to listen your experience on teaching
Yeah.
learning process.
Yeah.
Yes. We'll start at 1 o'clock, sir. Sharp.
Okay. So total time given is only 1.5 hours, like completion of my talk and
Yes,
then
sir.
questions, answers, whatever.
Yes, 1 hour or 1 hour and 10 minutes you can complete your that session, and remaining 20 minutes we will have question answer session.
Okay, so quickly I have to run through. Okay.
Yeah. Within 1.5 hours you have to complete
Yes,
entire
yes.
your that
Okay.
talk. Yeah.
Okay.
Yes. Mahawar sir, have you started recording? File, madam.
Yes, sir.
Yes, just a minute. Just a minute.
I think you can
Yes.
start now. Okay.
Madam, you can start now.
Okay.
Okay. Can I
Yes, sir.
have my video continuously or can I stop my video?
So sometimes you can answer. It will save bandwidth and your
Yeah.
voice will be clear. Otherwise, there will be some.
Okay, that's fine.
Yeah, 5-10 minutes you can keep it on. Later on, you can off your video.
Okay, okay.
Yeah. Yes.
Okay, sir. So shall I start the session?
Yes, madam. Yes, please.
Okay, okay. A very good afternoon to one and all present over here. I, Ms. Payal Taide, Assistant Professor from ENTC Department, on the behalf of AISSMS COE, I would like to heartily welcome to our today's so experienced resource person, Dr. C.B. Rama Rao sir, all cooperative event coordinators, and my dear participants. यस्य कृत्यं न विघ्नति शीतमुष्णं भयं रति समृद्धिर समृद्धिर्वा स वै पंडित उच्यते. It means one whose task is never hindered by cold, heat, fear, love, prosperity or lack of it. That person is really a superior person. Today, we are very fortunate to have such a superior and great personality with us, Dr. C.B. Rama Rao sir. Once again, I welcome you, sir.
Namaskar to all.
Highlighting more about sir's profile, sir has completed his BTech degree in Electronics and Telecommunication branch from JNTU College of Engineering, Kakinada in 1979. Followed by that MTech degree in Instrumentation and Control System from JNTU College of Engineering, Kakinada in 1981. Sir is having huge teaching experience of 4 decades. From 1982, Sir is still working in NITW, REC Warangal. Sir has completed his PhD from IIT Kharagpur in 1992 in Convergence and Tracking Behavioral Analysis of some IIR adaptive algorithms. Sir is an IEEE member, fellow member of IET and lifetime member of ISTE. Till this date, Sir has guided 6 students for PhD. His area of research includes mainly audio, video, biomedical, radar and the speech signal processing. Sir has total 50 publications in various reputed journals. Sir is also designated as Associated Dean Academic Affairs, Head of ECE Department, Warden and Deputy Chief Warden too. Sir also visited Hallam University in 1995 under India-UK Research Project. Thank you for being with us, sir. Now, without doing any further delay, I would like to request Dr. Rama Rao, sir, to proceed with their session.
Thank you, madam. Thank you
so
for speaking about me. Very good words. Okay, thank you. So, good afternoon to all. So, welcome to the session, a project-based learning session. Actually, the project-based learning is the title of this development program, faculty development program. We can say it is a faculty development program. Not only that, the students are also learners in this. Okay, I think second year students particularly, this in the curriculum, project-based learning is in the curriculum introduced for the second year BTech students, ECE students, right? Am I right? Second year BTech ECE students. Actually, what I say about this is, this project-based learning, let us say engineering domain, let us generalize it, not only ECE, in general, okay, learning, subject learning. So getting the knowledge through the learning process in a particular domain, in a particular area, it may be engineering, it may be commerce, it may be law, it may be anything, let us say. So project actually is the utilization of outcomes or utilization of the knowledge in the form of application. See, a project means, see, people with learning and getting the knowledge, they are applying the learned knowledge to a particular, formulating a particular problem. That is called project-based learning. In general, learning is for utilization. In general, projects are those which are to be used by society, mankind, whatever. That is the objective of a project in general. So, Now here, project-based learning for the students, for the faculty, whoever, okay, while they are learning, while they are in the learning process, okay, how to formulate a project, how to conceive a project, and how to find out how to formulate the objectives, and then the so-called modeling, designing, implementation. These are all various aspects, subcomponents while carrying out a project as such. So a project starts. Actually, we can have many perspectives. One of the important perspective is students' perspective, because this is the curriculum part in the learning process in this subject, right? People are learning, right? So a project concept, how you have this concept of a project. Not a lab experiment, a simple lab experiment cannot be called a project. Okay? A simple lab experiment cannot be called a project. But a project consists of, okay, some carrying out of some innovative thing, something like, you have to carry out certain, investigations, which are somewhat novel in your understanding or whatever, in your application. Okay? You want to implement them, you want to validate them, those concepts, those innovative things you are creating, you are formulating, like that. So basically the learning is the domain of engineering here for us, domain of engineering subject knowledge. So based on the domain of that particular engineering domain, engineering knowledge, okay, knowing the technology, latest technology know-how, and acquiring the practical skills, okay, for implementing the project. Actually, implementation involves, okay, practicality. How you implement, with what tools you will do this implementation, what experimentation you do, okay, like that. So practical skills are necessary for implementing the project. Okay, let us focus on to certain case studies. This is what the title. Let us say, while learning, this is what the point. While learning, see, while learning doing a project is something. After completion of studies, project is some other thing. Okay, industry activity, the job in industry is something. These are all somewhat different, actually. Okay, we use the word project while you are learning. Project by students, right? Like that. For example, second years or third years level, let us say. Let us take the second year students and third year students. So at their level, what way you understand the project, what way you formulate the project problem, what way you find out the requirements of the project. Like requirements means what you want to do, what are the main objectives, what are the aims and objectives of the project problem. Then total overall project implementation system you have to know. So that system understanding is very important. What is happening in the implementation? Okay, you have to have first a priori that futuristic information, like what happens in the system, what is going on in the system, what is the activity in the system. Okay, like the system understanding it is called. Then design of individual blocks of the system, okay, with the specifications and requirements. Each block of the system may be something like a circuit, something like electronic circuit in our domain, let us say. So each circuit, you have to know how to design the circuit. After designing the circuit, okay, after validating the circuit individually, then you have to integrate the circuits, you have to cascade the circuits, whatever you say, use the word. Okay, you have to use number of blocks which are connected, interconnected for the overall system which you have formulated. Actually, which you have, for the problem, what you have formulated. Okay, so design of individual blocks of the system with specifications and requirements. This is important. For designing a circuit, for designing a subsystem or subcircuit, whatever you call, you need to know what are the requirements for the circuit. So from analysis, you will understand the requirements of the circuit. You have to know, you have to have analysis, first of all. of that particular block, that particular circuit, then design would be easy for you. Then only you know the requirements of the that particular circuit. They are called the specifications for that circuit, for that block, whatever you say here. So design of individual blocks of the system with specifications or requirements. Then next step is what? After designing, you have to assemble them, you have to construct them, you have to put them with the overall system you have to construct. Then you have to start doing the activity like implementation of the project. Okay, implementation of the project. After completing the project, after implementation, after execution of the project, whether your project, with that project, have you achieved your requirements, have you achieved the objectives, have you got them or not, you evaluate the performance of the project performance evaluation. With that, you can validate whatever you have aimed at, whatever objectives with which you have started, you can validate them, okay, by evaluating the performance. The performance evaluation is with your results. Whatever results you are getting in the implementation process, in the execution process, you are getting certain results through observations. Those results, with the help of those results, you will evaluate the performance of that particular system, what you have designed. Okay, then you will finally conclude, you will get certain inferences, and then finally conclude that yes, the project has been completed. The project, with this project, we have achieved this much. So accurately, whatever we have aimed at, whatever the objectives, all are fulfilled, almost like that. You have to conclude, and you have to have those inferences. If at all there are any limitations, you may have to find those limitations, small limitations. Then those limitations will go ahead for the project future. What is the future of the project? Future scope of the project, that particular project. Again, you have to concentrate on the limitations of that, that particular project in its future scope. That's what called future scope. So this is a general procedure, a general way of going with a project. Formulation of the problem, system understanding, design with the help of the analysis. Okay, then construction and all that, assembling, construction, integration, whatever you call, implementation, then results evaluation, results performance evaluation and validation, then conclusions. Okay, for example, let us take certain examples. As a student in the classroom, generally what you do, so please understand, classroom environment is something different. The project in a classroom environment where you are testing, where you are validating with the help of the instruments available in the laboratories, okay, in your laboratory, in-house, that means in your college, in your department laboratory, you are doing. Really, they're all prototype models. You are not testing the real time. You are not in the real time domain as such. So as a student in the classroom, a prototype model may be formulated. A circuit may be, okay, obtained, or multiple circuits may be grouped, okay, in that overall prototype model. Prototype model means a laboratory type model. A lab for the testing in the laboratory, you are developing the circuits, okay, like that. May be formulated and taken up as a, then you can take up that prototype model as a small project. What are the examples? At your secondary level, these are the examples. A secondary EC student, let us say, for example, a public address system. So you are observing in public address system what is happening. Okay, in an auditorium, in an open air auditorium, and in a closed auditorium, whatever it is, there is an addressing system, a public address system. You are observing, you are seeing. Okay, what is there in the public address system? What are the different things? What are the blocks? And what are the concerned circuits? Okay, analysis of those circuits, understanding, then designing, then assembling or constructing, then testing, validating, everything can be done. So public address system can be one example. A simple example I'm saying at secondary level, a public address system, a digital clock using the integrated circuits, a digital clock using integrated circuit, okay, a 3x4 timer, okay, as an stable multivibrator, you can generate one head, a clock wave, okay. using 3-5 timer IC. So that is taken and that is passed through certain counters. It is given as input to counters. What you want, divide by 60 you want, like seconds display you want, minutes and seconds display you want, even hours also you want the display. So for a digital clock, based on that, you have to have the block diagram first of all. Then you have to know what ICs are to be used for that implementation. So IC design, IC circuits design, you have to know some small circuits using that IC, what you are doing respectively you have to know, like divide by 60 counter. Okay, then what happens? After divide by 60 counters, what you do? You will use some BCD2 7-segment decoders. Suppose you are using 7-segment LED devices, let us say, okay, to display your seconds or minutes or whatever, let us say. So, okay, then a BCD2 7-segment decoder drivers, that is 7447 IC, okay, that is used. And the outputs are fed to connected to the LED segment devices, non-display devices finally. So what is overall here? A timer generating the one-head clock, and then a counter design, a divide by 60 counter design using the suitable ICs. Okay, decade counter ICs are there. Okay, 7493 ripple counter, I mean, that 4-bit binary counter ICs are there. Okay. So such ICs you have to use and design for divide by 60 operation like that. So that is about a digital clock. A digital weighing machine is another example. In day in and day out, people when you go out for purchasing something, even in the markets, even in the sweet shop, wherever you go, these digital weighing machines will be observing. Digital weighing machines are observed. What is there inside? What is in digital weighing machine? What the system? First of all, you understand the system of a digital weighing machine. Then, what are the sensors? Without sensors as such, there is no electronics. That's what I believe. Without sensors, everywhere you have to use sensors, or otherwise they are called transducers. General word is transducers. Okay? Okay? Conversion of one energy to another form of energy. That is called transducer. Okay, some of them are transducers who may be acting as sensors. You are hearing these words, sensors, IoT sensors. Nowadays, people are using these words. Sensors. Without sensors, okay, your aim is to convert a physical energy, physical variable energy into electronic variable energy, electronic energy, electronic. You are converting from physical domain to, you are changing from physical domain to electronic domain. That's what here. Then only your electron starts. Otherwise, no. So, electronics will start once you get the sensor output, the so-called transducer output, which is electronic in nature. Amplitudes are very, very small, millivolts like that. Currents are very, very small. Even ohms sometimes. Capacitances you may get, inductances you may get. These are all variables, circuit variables, electric and electron circuit variables, inductors, capacitance, resistances, and voltages and currents are signals in electrical as well as electronic. Smaller quantities belong to electronics, smaller voltages. So the sensors or transducers were suitable for electronics. That's what. Then the rest of the things are instrumentation domain things. Basically, there are two domains actually. Outputs of sensors. You can have two domains. One domain is instrumentation domain, instrumentation channel. Another domain is communication domain, communication channel. Both are using electron circuits. The processing is electronic processing. Okay? Electron processing. Again, end devices again, they have to convert back to, like in an instrumentation system, you are interested in measuring the physical variables, magnitudes. You are interested. That is a digital weighing machine. You want to know the amount of that mass. 1 kg sweet, you want to know. So accurately you want to know. This is what the importance of electronics. Accurately you want. Accuracy is with electronics possible. Accuracy possible with electronics. Otherwise, anything, any machine, any weighing system you can use for measurement. Where It's not that accurate as electronic means. So for accuracy, we are going for electronics actually. Okay, this is what an example for digital weighing machine. AC, power supply, a step-down transformer, a bridge rectifier, okay, a capacitor filter, then a voltage regulator, a simple voltage regulator, okay, required voltage regulator. Suppose I want 5 volts, 6 volts, okay, JNRs and avalanche breakdown diodes, they are used as voltage regulators. So by using them, finally you are able to get a constant, what is that called? DC voltage, which is the breakdown voltage of those breakdown diodes. So that's a system, a small system. You develop, you construct, you design a transformer, step-down transformer for your requirements. You design a bridge rectifier, you design a capacitor filter for your requirements. Okay, you design a regulator, voltage regulator for your requirements. Design. Construct, integrate them, put them, assemble them, test them. That is a small project, you can say. At second year level, you can say. At third year level, integrated circuits are there. IoT sensors you can use. Embedded systems projects people can do. By the time you are studying all these digital microprocessors, microcontrollers, embedded systems, you are studying in third year, mostly. Digital signal processing, you are starting in third year. Parallelly, you can apply that knowledge gained in the learning process. You are formulating the problems. You are implementing those problems. By the time you are learning C programming, C++, you are learning how to use MATLAB. You are learning how to use MATLAB, at least by the time, second year. You are completing all these things. You know how to use the computer-aided design tools, CAD tools. By the time in second year, you are knowing how to use a computer-aided design tool, electronic computer-aided design tool, ECAD tools. With the ECAD tool, digital circuits. So tools are there. With the tools implementation, that is called. Okay, like that. Parallelly, every year, learning, finding a project. You are learning something, you are developing, you are understanding, you are converting your understanding, knowledge to formulate a particular problem, somewhat a bigger problem. You want to implement that problem and get satisfied. This is parallel process, like learning, doing the project, taking a project, learning, take a project, learn, take a project. Learning and doing the project, they are together, you can say. That is why you say learning, project-based learning process. That is the link between your learning and projects. Project-based learning, why not? All your learning will have, you can conceive projects with all your learning. That is what. So project-based learning is actually the project-based word. It is implied in your learning process. It is implied. Otherwise, why you learn? What for you are learning? Not to do a job in the industry. Finally, that is a job in industry. Again, you get trained there. You need a training to do the job in industry. That industrial environment, exposure in industry, facilities of industry, you are using and you are applying your knowledge of your degree. Then you are carrying out a project there. It's not called a project. The utilization for the society. You are developing a product there. You are manufacturing a product there in industry. Okay. In industry, you have to develop a product finally. Whereas as a student in engineering, as a student in the learning process, small prototype models are developed. A small project is developed, conceived and developed and tested. This is a process. This is the difference between industry and institute. Okay. This is what. Next. So in all these above, use of sensors, amplifiers, signal conditioners there, data converters are used, use of digital electronics, okay, like counters, BCD systems, decoders, display devices like LED, LCD display devices, design, construct and assemble all required circuits, testing, validation and verification, Okay, validation and verification of achievements of objectives. Have you got your objectives satisfied with your experimentation, with your results after implementation of the project? You have to verify. Okay, like that. So for designing, the students have to do the analysis for the concerned circuits and get the specifications for the design. This is about a small project. When you are studying, when you are learning, while you are learning, you can have small projects. It is something like a big experiment. Okay, big lab experiment. A small project may be treated as a big lab experiment, I can say. Next, mini project concept. Nowadays, you see, in the new education, what is it? National education policy, new education policy introduced by our MHRD. Okay, in every college they are introducing a mini project is to be done by the students. Mini project concept. Okay, mini project. A mini project may be something higher than your prototype models. A small project, what you are doing in your laboratory. A mini project. Okay. So they are encouraged to take up industry internships. Generally, you are all asked to go to industries and do the mini projects in industry. You know, you will have some vacation between the year and year. At the end of the academic year, after 2 semesters are over, before the next academic year starts, you find some time, at least 4 weeks to 6 weeks time you will find. So that time, the students, if they want to utilize, okay, in the form of a mini project, they can go to an industry, they can find out, okay, they can find out an organization where they can use the facilities of organization, do some work relatedly. Do some work relatedly. Relatedly means whatever you have known, whatever knowledge you have got, okay, you can apply that knowledge you can do a small project in an industry, in that environment. That is called mini project. So industry internships, they are called. Mini projects is made mandatory in all the engineering institutions nowadays. Okay, students are required to have exposure, understand the work atmosphere, environment of a particular selected engineering domain-based industry. Thus, students learn how to do a project in an industry. You know, once you know the atmosphere, industrial atmosphere, you know the industrial atmosphere, environment, you are coming back to the institute for your 3rd year, and after in the 4th year, again you are doing a big project in the 5th year or 4th year in the engineering, and you are ready to go to industry because you are familiarized with the industry, that atmosphere you know, that environment you know, how to do the work you know, how to do a group work. Suppose it's a group activity, how you yourself can involve in that group activity, you know, ethics you will be knowing, rules you will be knowing, safety precautions you will be knowing. This is what, okay, you are ready to go to industry that way. It helps you to go to readily to be absorbed by the industry once you successfully do your mini project in a particular industry. So thus, one more thing is here, institute-industry interaction will be developed. Institute-industry interaction. With that interaction, further and further, it grows. The collaboration grows. So many students go to the industries to do their internships. Okay, batch after batch, people go to the industries to do their internships, project internships. So in this interaction, human resources, personal managers of the industry, they will be observing you, how active you are, how intelligent you are, how you are doing, everything will be observed. So they identify your hardship, hardworking and intelligence, and almost there are chances to get absorbed in the industries. Once they identify you as a potential people for a job in that particular industry. Okay, that is about mini project. The next thing is a major project. A major project in the final year, generally, people will take up. So you have to see the levels. A prototype model, a small project in the 2nd year, in the 3rd year or 2nd year summer, 3rd year summer, utilization of the summer vacation time for doing a mini project, particularly mostly in industries. If you get a chance, okay, select an industry or your college people, your placement cell of every college, placement cell, they may find out some internships in some industries for the students. Okay, you can go like that. That is mini project. The next level of project is major project. Major in the sense, in the UG level, what is a major project for UG students? Final year. A project in the final year. Now, what way you do the project in the final year? What things are required? There should be some novelty. You should select some area. By the end of the third year, you are acquiring the knowledge. All fundamental knowledge you have already acquired by the end of the third year. Okay. Now you have to challenge yourself. Which domain, which area I want to select to do my main project, my final year project, like that. Okay. What are the different areas? Choice of the project domain is important. What are the various domains? For electronics and communication engineering students, we are seeing here communication engineering in one broad domain, instrumentation engineering in another broad domain. Instrumentation is clubbed with controls. Instrumentation controls, they are together generally. So embedded control, embedded systems, okay, these are all involved in the instrumentation, particularly digital methods, digital techniques, okay, digital designs, okay, embedded things, VLSI, all the subjects, whatever you are studying, whatever you are completing by the end of the third year, they are all used actually for selecting the problem. So communication engineering, instrumentation controls, VLSI, microwave radar, optical, multimedia communications, audio and video signal processing, biomedical signal processing, medical image processing, satellite image processing, IoT, Internet of Things, it is called IoT related projects, security related aspects in networks, okay. So security, cyber security, network security, secured communication, okay. Electronic warfare systems in defense electronics, okay. Radars, how radars are used, or how communication equipment is used for securing the data, for security purposes, okay. So like that, you have various problems you can select in all these domains. Okay, camouflage image processing, camouflage images. What is camouflage? What is an image? What is background? What is foreground? Foreground objects, background disturbances, okay, background noise, background disturbances. So an image may have all these things, particularly in defense field. Let us say in greenery, in forests, in the defense, everywhere you have these images, colored images. Okay, so objects are of interest, but not the background or unnecessary things. You have to eliminate them. You have to clean them. Okay, noise cleaning techniques. Okay, denoising techniques you may have to apply. So various techniques, signal processing techniques you have to learn and apply them to implement those projects in that particular image processing domain. Image processing is one subject, okay, like that. So the subjects learned and understanding and formulating a problem, a novelty incorporation in the problem, and then achieving the objects, okay, modeling the phenomena, modeling the activities in the systems with the help of mathematics. You can understand what to do, what tools have to be applied, what way you have to have the signal flow graphs, whatever, like that. So some techniques, tools, implementation platforms are required for implementing the programs. Like, machine learning is methods, machine learning, deep neural networks or deep learning, FPGA platforms, DSP processors, of course, MATLAB, and some codes like VHDL code, Verilog codes, some languages like C++ language, C language. All these are used for implementation purpose. These techniques are used for implementing the project. Which technique you have to implement, which is having novelty. There may be some comparison of various techniques. You may have performance comparisons of various techniques. You have to find out some novelty in the existing works. So what way these things have to go? What is the role of mathematics? There is something like a role of mathematics in all this. What is the role of mathematics in a project? What is the role of mathematics? Without mathematics, can you do? Without the help of mathematics, can we implement? Can we do? The answer is no. Mathematics has a lot of importance. Linear algebra, that matrix theories, vector spaces, okay, and various transform techniques, okay. What is DSP? What is digital signal processing? What is signals and systems subject? Transform techniques, convolution, correlation, filtering, modulation, all those things, basic activities in signal processing, basic activities. Based on that, you have further activities. Digital signal processing, advanced digital signal processing, okay, probability theory and stochastic process, okay, application. Use of statistics, data analytics, probability theory, queuing theory, stochastic process, transform techniques. All these are to be used wherever necessary when you are implementing a project. This mathematics will support you to understand. This is called mathematics, the role of mathematics. How to go with project? How to go with project or how to go with research? So, at final year level, you are doing a project. You are ready to do even research also. Do you know? The BTech knowledge, the BTech students, like almost they are ready to do a research also. You select a project with which you can go ahead with research. A research focused problem you select for your project. A research focused problem you select for your project. Okay, that way it is possible. How to go with project and research? What do we do? Knowledge in the domain, that is very important everywhere. Knowledge in the domain is important. Base, concepts, state of art, applications, then base knowledge and broad area of the problem, or narrow area of the problem. Broad, first of all, base is broad. Base area is broad. Then your problem area, the problem choice area may be something narrow. Research area may be something further narrow. Like that. Base and broad area of problem. Development of some research directions. How you are getting narrow direction, narrow areas. From the broad base area, how you are going, how you are finding the narrow areas? In different directions. In different directions, the developments from that base broad area. So they are all called research directions. Okay. Concepts, state of art. State of art means latest know-how, latest state of art, latest know-how, technology know-how, and various types of applications, where they are used. Where they are used, applications. Otherwise, why do you do research? What is your research? What happens with that outcome of the research? Okay, is it useful or not? There should be some application. Then only its utilization would be. So this is what. So all this will be known with the help of a important step, literature survey. Literature survey. You see, literature survey. What is literature? What is that literature survey? What is existing? How many people have done? Many people have selected the area. Many people are doing the work. Okay, what way the works are different? One group work, somebody's work, what way it is different from some other's work? A third person's work, fourth person's work. there are 4 or 5 people, multiple people are doing the research. I mean, doing the work. So all their contributions, all their investigations, all their innovations, okay, they carry out, they execute the work, they give the results, they do the analysis, they do the performance analysis, they give the outcomes. They are all the contributions of those people. You are understanding those contributions. For what? You want to know. You want to find out a problem which is new. You have to incorporate novelty in that problem. Something novelty you have to incorporate. You have to find out from the existing works. That is called, all aspects doing research is something different. Developing research developments rather. Okay, from one to the other, second to the third to the fourth. Directions you are going, you are expanding into various directions. For that domain, research domain, for that domain of area, that is called literature survey. Thoroughly one has to do literature survey. Then you understand fully what is happening. With understanding fully what is happening, you can have idea how the problem can be, what the problem can be, what more can be done, what can be novelty in that particular understanding. People can do that. That's how. Problem formulation, that is the step. Problem formulation step. The literature survey helps you to formulate the problem, to incorporate the novelty, to overcome the limitations of the existing people's works. There may be some limitations in the existing people's works. They have contributions, plus points. They may have some limitations. Those are the negative points. You have to identify those limitations so that, such that those limitations will be your issues in your proposal problem. Those limitations will be issues in your proposal problem. That implies you are incorporating a novelty in that. In that problem, you are formulating a new problem. You are going into a direction to implement. That is called problem formulation. Incorporating novel issues. Then you give the aims and objectives. Aims and objectives of your proposal problem. You do some mathematical modeling. Always mathematics has to be used. Okay, improve your understanding, mathematical understanding, mathematical way of understanding your project, formulated project system. Once you formulate the project, you have the idea of the system, what you have to do. That system will be identified by you. System will be known to you. So you apply the mathematics to your understanding of the system, to the activities of your implementation activity. You mathematically model that one, mathematical modeling. Then implementation, you are using the techniques, you are using the platforms, various things you are using for implementing the work. So contribution 1, contribution 2, contribution 3, they are all based on your objectives. How many objectives you have? How many objectives you have for your proposal problem? Each one can be one contribution. Okay, one paper or two papers you can publish with those results parallelly. So implementation or execution. Then various continuous contributions. That's what various contributions. The outcomes of your implementation, they are called the results. They are called the results. Then you have to go for results analysis. You have to have the results analysis. You analyze your results. You have started with objectives. Have you got your objectives achieved? Have you got your objectives? Do the analysis of your results. Whether you have got the achievements. Novel issues are incorporated. Have you achieved them? Are there any improvements? What are the limitations of the existing works? You compare your results with the existing results. Performance comparison. You show your improvements. Any small limitations are there. You please highlight the limitations also. Don't hide the limitations of your work. You have to highlight your contributions as well as you have to put forth your limitations. If at all there are any limitations, you can put forth those limitations. With your understanding, with your implementation, you can put forth your limitations. What happens to the limitations? Those limitations will be your future scope. Your future scope of work will be based on the limitations. You will try to improve over the limitations. That is your future scope of work. Okay. These are all the conclusions. So you put the conclusions of your entire research problem work. Don't you say it's a project? Is it not a project? Doing a research, is it not a project? Doing research, is it not a project? 4 years, 3 years, you are doing the work. It is like a project. Okay? The outcomes of your research may be useful. They are useful differently. The outcomes of the research are useful differently for the society. An industry may take up these research outcomes. An industry may support you for converting your research outcomes into products. For converting your research outcomes into products, an industry may support you, may come in collaboration with you. They may take you to carry out, to convert your research outcomes into products, product development. This is what? This is what? Okay. So that is about a project as well as a research. According to me, doing research is also called a project. What not? Which is not a project then? Everything in the learning process, whatever you are doing, whatever hands-on you are doing, incorporating novelties, everything is a project. Maybe small, big. That's the difference. Small project, medium project or mini project, big project, research, like that it goes. So this is all about the people who are doing the work. Who are doing the work? The learners are doing the work. The learners are called students. Maybe UG student, maybe PG student, maybe research student. All are students only. Doing people are students. Who are the other side? Mentoring side. The concerned faculty. Now it is now perspective of faculty in this project as well as research. What is the role of faculty in a project, in a research? They are basically mentors. They are basically mentors. Guidance, because they have the vision. They should have the vision of the area. They should have the overall understanding of the area, applications of the area. Okay, like that. So they are basically mentors. They help they guide the people who are working, that is students. They monitor the work time to time, because are you going in the right direction or somewhere you are deviating from the right direction of your work? This tracking should be there. So every time, at every stage, you have to check. You have to check our results. I say this is an activity together. This project or research activity is a together activity. Okay, it is a guide student combined activity. That's what I have written. So vision should be there for the, particularly for the faculty member, the guide. There should be vision. Okay, vision means what? What happens next? What is previous? What is next? What is going to happen when the student is going on doing like this, carrying out the work like this? What is next? What is next? That vision should be there for the so-called guide or faculty. Enables effective, what is that vision? Vision enables effective channelized focusing for successful completion of the project. For successful completion of the project or research. So it is a guide student combined activity, combined effort. Without guide, nothing. Without student, guide cannot do anything. Guide only cannot do anything. See, this is not an individual's contribution, it is a contribution of together. Guidance student, student is main, student is workhorse. That is why in the publications, do you observe? In the publications, the student will be the first name of the contribution. The first name for the paper is student. The guide's name will be second. Guide is a mentor. Guide is showing the directions. Guide is motivator. Guide is, inspiration for the student. Inspiring the student, motivating the student, encouraging the student to do the work, showing the directions, involved with the student. This is what required. So it is a guide student combined activity, okay, and student is workhorse. Student name is the first name in the contributions. Thinking and follow-up is important at every stage of the work. Always you have to think. Are you going in right path? Are you going in right way? What is your knowledge? How you are applying your knowledge? What way you are thinking? What are further thoughts? Like that. At every stage you have to do this. Okay. This is what called role of faculty member. Role of faculty member. Next, coming to industry perspective. This is something different. Industry perspective is something different. Okay. In industry, what is requirement? Industry wants the products, salability of the products. Industry has to survive. Maybe many industries may be self-finance industries. Many industries may be private industries. Maybe the government collaboration, government subsidy may be there. Sometimes they may be combined with government. Government, private, public, it is called semi-government. There may be public sector units, let us say. Like that you have industry perspective. Need of the project in terms of public utilization or society utilization. This is important. Why? When the product will be salability will be there, it has to be utilized by the society. The product has to be utilized by the society. The product is developed. The product is manufactured by the industry. Okay. A quality product is developed and put into market by the industry. So that is important. That need is important. Market survey is important. Industry has to know, has to see the developments, what the requirements of public, what people want, what are developments going on. Okay, you convert those outcomes of the learner people, the outcomes of the researchers, the outcomes of the projects, you convert them into appropriate, suitable products. Product development. Product development. That's what the third step. Product development. Okay. Product manufacturing process it is. The cost, amount of cost involved. This is very important for industry. What is the cost budget related to finance? How much cost in the process of this product development or manufacturing process? What is the estimated cost, overall cost? A very important aspect for industry. A very important aspect for industry. So budget related finance. Next, other aspects like power related aspects, mechanical variables related aspects. For installation, for example, something installation has to be done. Every mechanical, the production people they are called. Mechanical engineering people, they are also called production engineering people. The production engineer is important in any industry. Production engineer or a mechanical engineer, they develop a product, how it has to be, how it has to be encapsulated with all satisfying the various mechanical related parameters or parameters, mechanical related constraints, how to satisfy the requirements, all those things. Mechanical variables related aspects. Okay, design process of the product. What is the design of the product? How the product is designed? Okay, then implementation. Implementation of a product means manufacturing process. You are developing. You means the industry developing the product with that process. So what things are required for industry? What things are required for industry? These are all the various managerial things, management related things required for the industry. They need to have planning. They need to have organization. How you organize the production process, manufacturing process. Planning is very important. Organization, directing the people, how you involve the people, how you direct, give the orders, give the directions, directing activity, staffing activity, how you incorporate, how you utilize your staffing, then coordination, how you coordinate multiple activities, multiple stages of the product in the manufacturing process, different stages. So coordination of the stages, team spirit, how you develop, how you incorporate the team spirit and enthusiasm in the working people, among the working people, engineers, technicians, okay, small level to top level, people are involved, small level to top level, okay, managers, executives, managers, executives, designers, technical people, technical officers, technicians, okay, even to this downmost level, smallest level, all are involved in the process of manufacturing. Okay, so there should be some team spirit. There should be enthusiasm among the people while developing the product. Stage by stage, the product has to be evaluated and refinements have to take place at every stage. Otherwise, what happens if you don't do any refinement? Suppose after 2-3 stages are over, suddenly at a particular stage you will find the product is not coming into a good shape. The product is becoming useless. Suppose suddenly you identify at a 3rd stage or 4th stage. What is the use? You have wasted a lot of money. In the 1st stage, 2nd stage, 3rd stage, you have wasted a lot of money. Finally, you are finding a problem related to the product. That should not be there. So at every stage, if you do the evaluation, stage by stage, if you do the evaluation and judge the quality, judge the process, refine the process, there itself you bring it back within the stage. Suppose you find some fault, within that you bring it back. Recycling process, it is called recycling process. Okay, in those industrial terms. Okay, like that, stage by stage evaluation, refinements. Finally, after giving the product, finally after developing the product, okay, what will be there? Quality control. You have to test the control. You have to test the quality, whether the product has come, whether the product is satisfying all the requirements, quality related requirements or not. Okay, quality control is one important section in an industry. The end product has to be tested for its quality. The end product has to be tested in the environmental. Any environmental effects are there. With respect to environment, with respect to its performance, everything, it should have high performance aspect. That is called quality control checking. High quality. Environmental issues will be there. Environmental issues will be there. In the manufacturing process, in the industry, is environment getting affected? Is environment getting affected? In your industry, with your process of doing all these works, what are the things those are coming out to pollute the environment? That is one important aspect. Environmental issues means environmental pollution control, how to deal with that one, all those aspects. Protection and safety rules. Protection and safety. Okay, suppose suddenly something happens in a particular stage. Okay, so it may lead to loss of life also sometimes. You see, Vizag steel plant, something happened. In a thermal power station, something happened. We are hearing these things. In a thermal power station, something happened. Some 2-3 people died because of that. Okay, in a Vizag steel plant, in steel plants in general, I'm just casually saying Vizag steel plant, but in a steel plant, there's an industry, big industry. Okay, suddenly something disaster may take place. Something disaster may take place. Okay, so always one should have protection equipment. fire controlling systems, protection equipment, okay, medical equipment. Suppose suddenly some first aid has to be given, some medical equipment has to be there, kit has to be there. Some safety rules people have to follow. Safety rules people have to follow. These are all some aspects related to protection safety rules. Ethics, anyway, in general, have to be there with people. Ethics, okay. If pollution arises in the industry domain, there is a need for controlling the pollution with suitable methods. Okay, then public health considerations are also important. Surrounding people, public, surrounding colonies, residential colonies surrounding the industry. Okay, okay, their health issues are also considerations. Okay, so the public health considerations surrounding those people, what are those called? Residential areas surrounding the industry. I do not know. I think I am deviating from our project-based learning aspects into something like industry-related perspectives, various aspects for an industry. Okay, like that. So under state government, river water utilization, there are projects. These projects are something different. In industry work, that activity is something different. Industry work is implementation, product development, product manufacturing process by an industry. Why don't you call it as a project? Is it not a project then? What not? What is not a project? Everything is a project. Developmental activities, all developmental activities are projects only. The project is a general word, according to me. Project word is general. Everything is a project. Okay. So river water utilization related projects. Okay. Power generation related projects. They are under state governments basically. Lots of hundreds of crores of rupees will be spent budget for those projects. Okay. Under central government, railway projects are there. Railways in railway projects are there. So these are all. So what are these organizations finally? The people who are working in that. The people who are working in those organizations. It is like a project. Some project. Okay. Some corridor, industrial corridor has to be developed between Mumbai and Nagpur, between Hyderabad and Warangal. Some industrial corridor has to be developed. How the development will take place? It is a project. Basically, it is a project. Those are the projects. Okay? IT projects. Industrial corridor development is a project. Okay? Health, public health related infrastructures development. Public health related infrastructures development means hospitals development, big hospitals development. So how you people develop the big hospitals? It is also a project by the government. Everything activity that is taken up by people, work done by people. What is government? For the people, by the people. People are working. That is called government. Okay, that's what our understanding is. Under central government, railways, under semi-government things are there, public sector units. Okay, many projects are under private organizations. Actually, under private organizations, there are many projects. Okay, these are all various aspects. Projects in industries. That's what industrial perspective. So industry perspective. Okay, faculty perspective. Students, learners perspective. Basically, project-based learning means the learner's perspective. Learner's perspective. Students' perspective. Students are learners. The people who are working in industries are employees. Not like learning there. It is not like learning in project industry. You have to do the work there. You have to implement production process. But as a student, you are a learner. So that learning, okay, project-based learning, yes, learning is always for utility, for utilization, for if you want to implement anything, if you want to do some work with the gained knowledge, that itself is a project. It may be a small project. mini project, medium level, high level, final project, whatever it is. Ultimately, learning is for project only. You are learning, acquiring knowledge, everything, getting the skills, soft skills, tools, knowledge, hardware platforms, process, whatever. You are applying, you are acquiring, you are applying. You are acquiring knowledge through learning process, you are applying. You are acquiring the tools, how to use the tool, you are applying. You are doing the work. You are doing the work. You are formulating the problem. You are doing the work. Thus, it is a project. Anything is a project. Anything is a project that way. This is called learning. Of course, project-based learning. I think, am I missing any points? People can suggest any interaction. I invite interaction by the people. Any points have I missed? You people can interact with me.
All participants are requested if they want to have a communication with Dr. Ramarao sir. The
Yes.
forum is open.
Welcome. Let us discuss something new ideas, something new, your opinions, ideas. You may share your ideas. But at secondary level, the secondary students can take up small projects. Like, a public address system. Take a microphone, sensor, 2 RC coupled amplifiers you design, 1 power amplifier, class B push power amplifier you design. You have a loudspeaker. You assemble them after designing, testing. You assemble them, verify. You develop a small radio of one particular, you generate a particular small radio station for your campus. That is also possible. You know how to use the integrated circuits to develop digital clocks, digital weighing machines. Okay, you can develop a digital frequency counters. All that. Floor is open for discussions.
Sir, would you like to say something?
Participants, if you have any questions, please ask, unmute yourself and ask the question.
Questions or ideas or anything. You can share your ideas.
Yes, sir. Hello, sir. Hello, sir.
Yeah, please.
I'm
Yes.
Sanjit. Sir. I'm Sanjit Ajeskar. Instead of having any question, I express my satisfaction, and I feel that your session was extremely useful and extremely impressive. Thank you, sir. Thanks a lot.
Thank you. All this is just I have written, whatever that is striking my mind, whatever I want to put forth, I have just simply have written all these things.
Yes, sir. It was a natural. Thank you, sir. Thank you.
Sir, when in your institute, you have introduced this project-based learning concept?
No, as such, in this project-based learning curriculum, we did not have this. We have, by other names, we have something like entertainment electronics or enjoy electronics is in first year, second semester, the new students, the present students, they have one topic called enjoy electronics. Something like electronics workshop, people are using there. Okay, in that name, enjoy electronics at the first year.
Other participants? Balke sir, are you there? Balke sir?
Yes, sir. I'm here.
Sir. Sir, do you want to ask anything?
No, it's okay.
Now, sir, you want to wind up? You want me to wind up the session?
Participants, miss, if you are having any questions or any suggestions or you want to discuss
I
point.
give something more advice to the students.
Yes, sir.
Secondary, particularly secondary students. Actually, second year is very important year for the students. Students have to have all that fundamental knowledge. Well, they have to well acquire that fundamental knowledge. And analysis, people have to know circuit analysis. The people should be strong in circuit analysis. When the students are strong with circuit analysis, obviously they can design the circuits also. The analysis and design, they go together. They're nothing like separate. Design is not separate. Okay? Analysis is theory. Application of analysis outcomes. The analysis outcomes are there applied. Okay? To develop a circuit, to design a circuit, the understanding of the analysis. So all the in this learning by electronics and communication students, they have to know thoroughly the analysis. They have to do the analysis thoroughly. Then they must be able to design those circuits and implement those prototype models, means laboratory experiments. Okay, implement the laboratory experiments, the designed experiments. So design is a part actually. Design, hardware development, troubleshooting in the laboratory. Suppose somewhere something is not working, you have to test, you have to troubleshoot the problem. Testing and troubleshooting, okay, should be there in that execution of a simple lab experiment while doing that experiment. Okay. All the DC conditions are to be satisfied. Suppose you develop a amplifier circuit, you design a bias circuit, cell bias circuit, you design the capacitors for your bandwidth, required bandwidth, let us say. Okay, you get ready with everything, and you please test first of all the what is that quiescent conditions, that DC conditions. Are you satisfied with the operating point? Center of the load line, is it established? If it is yes, your experiment, your circuit will work well if you establish the DC conditions. Yes. Then do the experiment. Frequency characteristic, for example, you are carrying out the experiment. Okay. So this much of the time you have to spend for laboratory. Electronics and communication students' laboratories, they should not be like simply 2.5 hours or 3 hours laboratories. You know, at least I say more than 3 hours laboratory, 4 hours laboratories. Why? You are designing, you are constructing, and when you are doing the experiment, before carrying out your actual experiment, you have to test the DC conditions. While doing so, you have to troubleshoot. You have to do testing and troubleshooting. You have to ensure the circuit is working well. Then only your experiment starts. Actual experiment starts. So, time taking. Actually, electronics experiments, design experiments, they take time. All design experiments in electronics, they take time in the laboratory. So, I
Sir,
do not know.
I have one question.
Yeah.
Actually, this project-based learning is one of the good pedagogical technique, which is a student-centric, where the student involve more and their learning ability is enhanced using the PBL. So, how the PBL can be applied to the courses. For example, signals and system, or the electronics devices and circuits, or the communication engineering. So how we can make use of the PBL for the courses to enhance their learning ability. So as you are having the good experience in the hardware engineering, the core electronics, just I request you to elaborate on these parts.
What you say is the subject's utilization in implementation, right? The subject knowledge
Yes, sir. Yes, sir.
utilization in the implementation of a problem. Okay. So let
Yes,
the
sir,
subject be anything like signal systems. When people understand signal systems, how do they validate? How do they test them? How, with what tool they have to find out, suppose convolution, some correlation, okay, some transformation. They have to use, because their signal systems is basically mathematical. We know that signal system subject is related to mathematics. It's a mathematics only, basically. Related to signals. Okay, related to signals, mathematics. So the mathematical operations like convolution and all those things. So the mathematics related operating tools, the people have to acquire those tools knowledge, implement how you find out a convolution given a two signals are given, how you find out the convolution, for example. So how to use what is that called, MATLAB, no? MATLAB, even Python. People are using nowadays.
Yeah.
In second year, it's a Python. Yeah. So how you are acquainted with the tool, Python or MATLAB or whatever, how you are acquainted, because that is one thing. People have to acquainted with the facility, with the tool. Then know various aspects in the tool, how to use the tool, to do the problem, to implement the problem. That is for signals and systems actually. For that, even PTSP, probability stochastic process problems. Okay, then signal system problems. People can use MATLAB. With MATLAB, people can solve the problems. Electronic circuits, analog circuits, digital circuits, simulations, hardware implementation, tools implementation. There are two ways of implementation for all these electronic circuits. Okay, that is the last step in the process. The first step is problem, statement of the problem. Like devices, if you want to see device physics, device characteristics and behaviors, device modeling, device as an equivalent circuit, and circuit, application circuits, analysis. Okay, then design for implementation. Practical. Implementation is practical. Actually, hands-on is practical. Hands-on is practical. That is implementation. Don't call it as a project. Simple things are not projects. They are simple experiments. Okay. So these knowledge application, these tools are these, when you are designing, when you are understanding analysis, you have to apply all Kirchhoff's laws for analysis. Okay. After analysis, you know the requirements. Then those requirements will be specifications for the design. You design the circuit, then you do the hands-on. You select the PSpice tools, analog circuit simulation tools, Tanner tools, PSpice, people can take up. They simulate the analog electronic circuits. Digital circuit simulation, Altera tools and some other tools, okay, Xilinx tools, people can take up and simulate the digital problems, digital hardware descriptions. That's what VHDL code, Verilog, these are used for describing the hardware of the digital circuits. Okay, then implementation with hardware, like devices, components for circuits, integrated circuits for circuits, digital integrated circuits, analog integrated circuits, discrete circuits with devices and components. Okay, design, construct, test. That is what doing. That is what a small project. Multiple circuits to develop. Let the people develop an op-amp integrated circuit. Let the people design. First stage different amplifier, second stage different amplifier, emitter follower stage, level shifter stage, output stage. Let the people design independently, individually, each block. let them design, let them test, let them integrate, let them assemble them. Overall, let them test how much CMRR people are getting, how much differential gain people are getting, how much common mode gain, how much CMRR. You do the frequency response experimentation, find out the bandwidth. You find out the input impedance, find out the output impedance. That itself is a project. That itself can be a project. Students are developing with discrete components, devices and components, an op-amp. An op-amp they are developing. They can develop, design, construct, develop. You test it, evaluate it. That itself can be a project. This is how the knowledge is put into for implementation of the project. Sir, am I right and have I addressed your query?
Yes, sir. Yes. Thank you.
Is it okay?
So can we, sir, shall we call this simulation or the hardware implementation as a project-based learning, or it should be application-oriented?
Yeah, project is application only. What is the project? That is the application of knowledge. Learning gives knowledge. Knowledge is applied for hands-on work. That is the project. So that is the link between the learning and project. Learning through learning knowledge, knowledge applied to develop a system, developing a system, applying the knowledge, which is learning based. Finally, you are getting a project implemented. Am I right, sir?
Yes, sir. Yes, thank you, sir. Thank you.
I think have I addressed the query? I mean, is there any other
Yes, sir,
opinion? Is there any
Excuse
other?
me, sir.
Yeah.
Excuse me,
Yes.
sir.
Yes, please.
I have one question. The PBL laboratory experiment is doing using software as well as in breadboard also
Okay.
for the ECE students, sir.
I am unable to make out, madam. Please talk again.
The PBL laboratory experiment is doing using software as well as in breadboard also.
Yes. See, implementation in two ways. One implementation is tool implementation. Another implementation is hardware implementation. In both the ways, you can do the implementation of a particular experiment. So CAD tools are used, ECAD tools are used for simulations. Okay, tool implementation, that is. If you take up the devices, components, hardware related, that is hardware related circuit, you can implement that hardware. Okay, you can match the results. Simulation, simulation with tools and your hardware lab experiment design and development and testing, both the results can be compared.
Okay, sir.
I think,
Thank you,
yes.
sir.
Yes.
Any other participant?
Sir
Yes.
is a hardcore teacher actually. He's having more than 30 years of experience. And we have learned so many things from you, and you have spared your valuable time from your busy schedule. So, sir, we are very much thankful to you for accepting our invitation and giving knowledge to all of us. Definitely, it will be useful for us to implement project-based learning.
Okay.
Over to you, madam. You can propose.
Okay, sir.
File, madam.
Thank you all. Thank you. Thanks to all participants, all
Thank you,
faculty, whoever
Thank you.
is listening to me. Thank you all.
Thank you,
so
sir.
much.
Okay. Thank you.
Thank you so much, sir, for making us understand that what should be the steps for implementing PBL. Also, guidance about mini project, major project, importance of mathematics in research is really appreciable, sir. And we are very glad to get input on role of faculty and industry perspective as well. overall the session is really wonderful, sir. Thank you so much for your valuable knowledge and the precious time.
Thank you, madam. Thank you all.
Thank you, sir.
Madam, we'll take a 5-minute break. Meanwhile,
Okay, sir.
will join and we'll start the session at 2:30.
Okay.
Thank you, sir. Thank you
Okay,
for
Thank you very
coming.
much.
okay.
Thank you so much.
Thank you.
Yes. Now you can leave the submit. You can leave the meeting.
Okay, okay.
Yes, sir. Thank you.
Participant, please don't leave the meeting. Just Bhatlavande sir will join and we'll start the session.
Now, sir, you can share the screen of Bhatlavande, sir.
So am I audible? Balke sir, Mamade sir.
Yes, sir. Yes, you're audible. Welcome. Welcome.
Yes,
This
thank
is
you.
Payal, madam.
Yes, sir. So
I
you
think you
want me
can
to start
start.
the session?
Yeah, yeah.
Mm.
Sir,
Okay.
Bhatlamani sir, shall we start?
Yes, sir. Just 1 minute, sir. Actually, I am just setting other computer also
Okay,
because
okay.
today some
Okay.
UPS like repairing is going on actually. So I'll just keep it
Okay, sir.
ready.
We wait.
Yes, right.
Just let us know when to start.
Yes, sir. 1 minute maximum. 1 minute.
Yeah. Yes.
Yes,
So
Bhalke
you
sir.
want me to start
Yes,
with the
yes,
session?
yes, madam.
Yes.
Madam, just before
Okay.
that, just I'm okay. This is what. Can you just like provide me rights for sharing my presentation?
Yes. Absolutely, sir. Mawe, sir?
Yes, sir, you are presenter. Just after your introduction, you can share your screen, please.
Okay, but sir, that those rights are not with me. Still, it is showing you can't share.
Sir, so you are there in presenter list. Okay, sir, we'll check.
Okay.
Madam,
Okay.
you please.
Always,
Yes, sir.
surname is there in presentation. Presenter.
Ah,
Yeah.
So I have
sir
joined
is there in.
using two machines actually. So maybe
Okay.
Yeah.
Okay, sir.
right.
I will check, sir.
Right.
Okay, sir, I'll start with the session then, sir.
Okay. Yes.
Meanwhile, Mawe sir will check the how we can give the presentation authority. Okay, sir. Once again, a very good afternoon to one and all present over here. I, Ms. Payal Taide, Assistant Professor from ENTC Department, on the behalf of AISSMS COE, I would like to heartily welcome to our today's dynamic resource person, Dr. Shripad Bhatlavande sir, all helpful event coordinators, and my dear participants. It is rightly said that you need to surround yourself with quality human beings that are intelligent and have a great vision. Today, we are very fortunate that we get a presence of such an intelligent and long visionary personality, Dr. Shripad Bhatlavande, sir. Once again, I welcome you, sir.
Thank you, madam.
Thank you, sir. Speaking more about Sir's profile, Sir has completed his BE from SGGS Nanded in 2000, followed by that ME from Government COEP Pune in 2008 and PhD from IIT Kharagpur in 2015. Sir is having total 20 years of experience. His main research interest includes in machine intelligence. Sir is having total 9 paper publications in reputed journals and 2 patents too. Sir is guiding 5 research projects and get grant of worth rupees 50 lakh. Sir is also linked up with the consultancy worth rupees 2.5 crore. Currently, Sir is designated as a professor and Dean of Industrial Projects and Consultancy, and also Head of the Department of EITC Engineering in Vishwakarma Institute of Technology, Pune. Thank you for being with us, sir. Now, at the earliest convenience, I would like to request Dr. Shripad Bhatlavande, sir, to proceed with the session. Over to you, sir.
Madam. Yes, thank you, madam. Right. So, madam, just I'll take 1 more minute to share. Now, sharing rights are there, so I'll do that.
Sure, sir. Sure, sir. Sure.
Yes. So, madam, can you see my screen?
Yes, sir, I can see, but at this moment, yes, now it's visible, sir.
Presentation is also
Yes.
on? Yes, you can see.
Yes, yes.
Okay, right. Yes. 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 Thank you, madam. And thank you, Professor Bhalke, Professor Bormane sir, and the entire organizing team at your institute. So thank you so much for this opportunity. So yes, so I was following all sessions, and very good afternoon to all participants. Yes, so since last few sessions, like I have been following few sessions, and they have already spoke about what is project-based learning, and then the different assignments or case studies related to project-based learning. So everyone has discussed this topic at a good length. So today we will be discussing about 2 aspects of project-based learning. The first aspect is ethical practices. So we'll just quickly run through what ethical practices are there, and like how one should like imbibe those like things in one's personality. So we'll just try to discuss about those things quickly. Then meaningful teamwork. So how one should be a good team player, and once like we become good team player, we become good team leader as well, right? It's just in the course of time that transition happens. So how it happens, so we will discuss about that as well. Then project management. So we have been hearing about projects and project management. So are there any simple rules to manage project? Management's complete without creating any sense of urgency, any pressure on anybody. How to do that, right? And what are like basic rules for that we will discuss in project management. And then finally, yes, we'll conclude our session. Fine. So we'll start with our first subtopic, that is ethical practices. So ethics. Now, if you see, madam, if suppose in between, if I'm audible or if presentation is not visible, please let me know, madam. Yes. Madam, am I audible?
Yes, sir. Yes, sir. Yeah.
Okay, right. Yes, Mawani sir, you are there, right? Okay.
Yeah.
So, sir, if suppose somehow my presentation is not visible or if I'm not audible, so please let me know.
Yes, sir.
So, ethics. So, ethics is what ethics has many definitions, and one of the fundamental definition of ethics is philosophy of morals. Morals and ethics are different, basically, but the foundation of ethics is morals. And if morals are there, then ethics are there, right? If morals are not there, then ethics are not there, right? So morals are building blocks, basically. Morals are foundation of it. And on this foundation, if we see what is built, that is ethics. And what are the components of ethics? Responsibility. It starts with responsibility. So what is responsibility basically here? Responsibility is what? See, responsibility is a thing which cannot be delegated, right? I cannot like ask my team, okay, now take this responsibility and now start delivering it. It's not possible. The responsibility cannot be delegated. Responsibility is such a thing which we need to take up. And whenever we take up any responsibility, it provides us great learning, amazing learning. So we can't delegate it. We need to take it, basically, right? So responsibility, then capability. We cannot define capability of anybody. We cannot comment on capability of anybody, and we cannot describe anyone's capability. Everyone has certain strength, weaknesses, capacity and strength, we call it as. So everyone has to introspect, analyze oneself, himself, herself, and based on that come up with capability analysis. So we cannot measure anything called capability. We cannot say that, okay, this is his capability or her capability. No, we can't say that. So everyone has to analyze and understand one's capability. So only I can understand my capability, right? And I need to do that assessment, and based on that I can draw my conclusions. So everyone has its own plan, everyone has its own philosophy, and everyone has his own course of actions and repercussions, and then finally conclusions, right? So we need to, or otherwise we are accountable for our conclusions, our actions, and our actions will lead to conclusions. So we are accountable for our conclusions. So actions and in turn conclusions. So we should be able to draw conclusions. What we are doing, we know. So that's why only we can draw some conclusions on our actions, basically. Reasoning. No, reasoning is what? Now we see, no one knows in what situation we are, basically. We only understand our situation, our, what you can say, favorable conditions, unfavorable conditions, our resources, right? So our awkward situations, right? So many issues, so many problems, difficulties are there, but external world may not understand it, right? And only we can understand about those things. So, and then what is our reasoning? Because problems are always going to be there. So what is our reasoning? What are our excuses, basically? If suppose some work is assigned to somebody, and if suppose he has so many other excuses, so how those excuses can be used to procrastinate that work, or to avoid that work, or to postpone that work, that only I can decide, right? Nobody else can dictate me or tell me that, okay, and this is your problem, and because of that you are not able to do this. Only I can decide, and I need to decide how to give reasoning for something good or something not good, basically. And then relevance. If suppose I'm working on something, and if I'm doing generally it is said that we should do right things, but first of all we need to understand what is right, right? If suppose we are thinking that, okay, whatever we are doing is right, then that is problem, right? Rather we should always do right things. So but for that we need to basically identify, we need to understand first what are right things, or what is right thing, and based on the relevance, its definition cannot change. Means at one instance or in one case something is right, and in other case it cannot be wrong, basically. Relevance cannot change anything, basically. Things are absolute, and those absolute things will remain always absolute, right? So relevance cannot change it, basically. So for that, first of all, we need to understand that it is relevance independent, and what is right, what is wrong, what is not right, that we need to decide and define. And while doing everything and anything and everything, we need to always keep one thing in our mind, that it should not hurt anybody. It should not hurt anybody, right? So these are very basic things of ethics, right? This is standard definition, or you can say broad definition of ethics. But one thing we need to understand, ethics without morality is zero. And we cannot teach ethics, we cannot teach morality. One has to basically follow certain principles. One has to live the life according to certain principles, right? And ethics, morality, this is qualification basically, and this is rather practice based. You cannot, like, we cannot teach ethics and morality. We need to follow certain processes, right? And ethics and morality processes are based on spirituality only. So if we teach everything and not spirituality, then we can't think about ethics and morality or ethics and morals. So that is what byproduct of spirituality. So we have to be like part of that process, then only we can imbibe those things. If we learn, if we are alumnus of great institutes, if we are working in great companies, if we are, companies means industries also and association also, friend circles also, people around us. So that doesn't matter actually, how big we are, how small we are, but what principles and how we are living our life, that is decided by spiritual principles. And if we are not following that, it's of no use basically. So the first conclusion here, just I would like to, or this is my opinion again. So without spirituality, no ethics, no morals. But again, like, you know, there are like there are two domains basically. People says that morals, dimension of moral is spirituality, and dimension of ethics is material, like what things, materialists. So material things. So in material world or material things, basically, we see that like what motivation can be, or ethics can be taught, morality can be taught, right? So there are many examples of ethics. There are many types of ethics. So we need to just decide which type we like or which type we are basically, and based on that we need to act. So these are basically types. So the first type is inspiration. So just simple video is there basically. So one just small disclaimer I would like to just like display here. See, there's all like what in a video, small videos are just like used for conveying the message, right? There is no intention of hurting anybody, and there is no relevance of anybody here basically, just a message. So please don't misunderstand anything. Okay, so the first type of ethics is inspirational. So we can like very like in a fancy way we can teach ethics. So one of the simple example is what this is a simple example of inspirational ethics. I hope this is audible. Sir, is it audible video?
Yes, sir.
Okay.
Let's get ethical. I want to get ethical.
So how we want to like inculcate that ethics, it's up to you. Just today morning only, like, you know, we must have read in newspapers, on videos also, on news also. It was there, this news was flashing actually. There was one motorman, he stopped the train to get the kachoris basically. So he thought that is right. He thought this is right, there is nothing wrong in that. He can stop the train. Stopping train, you can understand what implications. Yes, sir. Yes, sir. Mavale sir and madam, if possible, can we just
Yes, I'll unmute.
Yes, participant. Yes.
Unmute.
Okay. Yes, thank you.
Yes, sir, you go ahead.
Okay, right. Thank you, sir. So today morning, like this was a news basically. So one motorman stopped the train, and this is his regular practice. There is no train like what in a signal or what you can say railroad crossing, nothing, right? Crossing, I mean the crossing gate basically. So there is nothing, right? No safety measure, nothing. And we know that like the train runs with respect to some times and semaphore, that signaling they have, even though technology is there, but still like, you know, it is very serious thing. So this motorman stopped the train to just get kachoris. No, with what understanding he is doing that? So he only understand it, right? So everyone defines ethics based on some purpose also. So we need to decide whether this is wrong or right, basically, right? And any person with common sense can decide. So this is another example of ethics. This is called as payback. And we know, like, being a researcher or being a teacher, being the author of many manuscripts, so we know that, like, basically whenever we refer any other author's work, so we do the same thing, right? If you see them, this. So we think that, see, these 4 thieves robbed everything from his home, basically. This person, basically. So they robbed everything, air conditioner, computer, right? That robots, everything, his all belongings, right? They robbed everything. And then finally they saw something like some chocolate, I think dairy milk or something, right? So they saw it and then they decided to share, right? So we think that, or people think that, or students may think that, okay, we are referring someone else's work. We liked it. It's very impressive. It is very useful. So let us use it. Let us take it, do some incremental changes. And in return, what should be given to him? You just see what these thieves did basically just before some time, what they said, what they did basically. Just one bite of that chocolate they are giving him. That's it, right? So in our practices, we think that, okay, once we cite somebody because we referred his work, we used someone's work, and now what we did, we just provided citation, right? And our job is done now. Like, our responsibility is over, right? So this is again like payback kind of ethics are there. So we need to decide, like, is it really sufficient? Because we have taken everything from him and we are just giving one citation to him. So does it, like, what, what, like, is it enough for referring his work or someone else's work? Right? So we need to decide. So this kind of ethics is called as payback ethics, basically. And then one more, preaching. Preaching is also another. So this ethics is called as actually preaching wala ethics, right? So we need to decide basically. So in which ethics we are basically, right? And we need to decide like what we want and what we don't. So there are different types of ethics, and we need to decide which one is like suitable for us. But as already like what many books and many philosophers, they say that we can't teach ethics basically. It is a practice basically. We need to lead the life that way by following certain principles, right? We need to practice it. When we practice, then ethics is contagious basically. Just like COVID virus, ethics is also, and morality is also contagious. When we see somebody following all principles, somebody following good rules basically, somebody is helping others, somebody is like recognizing everyone's efforts, right? Somebody is respecting feelings of others, right? We also start following him or her, right? So ethics and morals are very contagious basically. Anyway, so that was the essence of this. Now meaningful teamwork. So meaningful teamwork. So teamwork is what basically is responsible. Now any project, we have been like what working on projects since long. So everyone like attending this session may be having more than like 15 years of experience, right? In teaching basically, in academia or in industry, right? So since long we have been working on projects. So what is new in project-based learning, right? So the new thing is what basically teamwork, that's it. Earlier also teamwork was there, and now also teamwork is there. But here there is some purpose, some higher purpose is there. We like see project-based learning as, see, that's why learning word is there. We just don't call it as project. There is learning also, right? Learning also. So project-based learning. So we are learning through projects. So here our focus is not on like one working model. Our major focus, our major emphasis is on like we are emphasizing one very important aspect of this work is what? Learning. And that learning is also what type of learning we are talking about? Collaborative learning. Because in any group, minimum 3 to 4 or 5 students are there. So if they work in good spirit, if suppose they follow a good coordination, if they maintain good coordination among themselves, right, then that will be called as teamwork, right? And if suppose teamwork is good, then there are many returns basically. So if teamwork is good, many returns are there. And one of the major return gift or major return is what? Basically learning. And learning of everyone who is part of that activity or that group, it ensures learning of everyone. So meaningful teamwork is very important, right? So how to get that meaningful teamwork? And here, being teacher, our role is very important. So whenever we form, because anyway, see, even though we are calling it as project-based learning, but same people are there, same philosophies are there, same students are there, same setups are there, right? So here only one thing is new, and that is what basically mindset, right? And here mindset is based on now, or we may call that mindset as mindset of learning basically, right? So that is the only difference here. And to ensure that our role is very important. And it is said that there are 7 C's. They are catalyst for good teamwork. If suppose we follow the 7 C's, or if suppose we ensure the 7 C's among our students, then comfortably there will be a good teamwork. We need not worry about anything. We need to just emphasize these 7 C's. And if we could emphasize these 7 C's, then comfortably everything will be taken care. So we need to just ensure, let us say 4 members are there, 4 students are there in one group. So, or such multiple projects are there, right? So every teacher maybe handling maybe 4 to 5 project groups, right? So if we follow the 7 C's, or if we implement the 7 C's among our students, then this is just one-time investment. We need to do this experiment with just one batch, that's it. If we do it with one batch, then comfortably, this 7 C's are also contagious. If we do it with one batch, automatically, it will be passed to next batch, incoming batches. So what are those 7 C's? We will just quickly see. So choice, then creativity, critical thinking, collaborations, communication, context, and conversion. So these C's are very important. And the 7 C's are a recipe for great teamwork, great returns, great learning, basically. So now one by one, we'll try to understand what are these, what is meaning of each C here. So we'll start with first C. So teamwork, how to develop a good teamwork, basically, or how to develop a good team, basically, right? So the first thing is what? If we want to develop a good team, then we need to follow their likings. We need to follow their likings. We cannot just directly dictate the team. We cannot say that, okay, you just take this topic and you start work on it. That's it, right? No, it's not possible. We need to appreciate their choices, right? And we need to ensure capacity, that ability should be developed among our students, right? So already everyone has his own choice, right? Choices, right? And we need to just understand, and we need to just dovetail or mold them to suit our purpose, right? So choices, now 4 or 5 students are there. We assume now 4 students. Throughout this discussion, we assume there are 4 students, let us say. So now what happens? That all 4 may have different choices, different mindsets. So somehow we need to bind them together, right? Keep them together. And for that, we need to understand their choices, and we need to behave as per their choices, right? Behave here, behave yourself, while behave, not behave, right? Behave means, see, because any project has some outcome, right? Learning is one of the major outcome, but again, some deliverables are also there, right? And somehow we need to get those deliverables, timely deliverables. Different schedules are there. We need to make different schedules to achieve those deliverables, right? Those basic targets, right? So we need to follow them, right? We need to follow them. We need to sometime appreciate them. We need to sometime provide some keep some penalties, some rewards, right? So choices are there. So choices is what now you can see here. Generally, we always give this example to our students. This is cafeteria. Now in cafeteria, we need not dictate them. They voluntarily go to counter and like what they place the orders, they get the things of their choice and they enjoy, they discuss and come and go back to their home, hostels, wherever like they are staying, right? So this is general scene. So whenever choices are given, they are very happy, right? There are so many choices. So they like choices. Students like choices. Everyone, whoever want to do anything, like choices. Even if we want to buy something and if many choices are there, we enjoy it, right? And we use our discrimination, we use our common sense, and we choose what is good for us, what is best for us, right? We start like what comparative analysis of our strengths also, and based on that, we choose something, right? So when choices are given, then there is discussion. And when discussion is there, analysis is also there. And when analysis is there, then good outcomes are there. So that's why providing choice is very important. Because when we provide choice, people are very happy. People are like what? Then they start helping themselves. And it is said that whoever is ready to help himself can achieve anything. Because the Supreme Personality of Godhead also helps them who wish to help themselves, right? So basically self-help or self-learning, here we can say that, right? So they enter into mode of self-learning. So this is power of choice, providing choice. They make many plans, many strategies, and based on that, sometimes some plan may fail, sometimes some plan may work, right? We are always there to guide, but choices can help them to make their own plans, right? And deals also, right? Deals means what? No, 4 members are there and some choices are given to them. They can distribute work among themselves, right? They can make some good deals. Okay, one will do this, one other will do that, third will do something else, and fourth will write something, right? So that way they do some deals, and we can also finalize some deals, good deals with them, basically, right? So we can give some good targets. Here deal is learning, that's it. For us, deal is learning, that's it. So our deal will also be, our purpose will also be served here. So choice is very important. So somehow we need to inculcate the culture of providing and respecting choices, right? Because everyone like variety, and when we provide variety, people appreciate that, right? Because everyone like freedom. Okay, right. Okay, then the next is what? Basically problem statement. See, now once like we have given them choice, so now how like team will be developed, we need to just understand. Now we have given them freedom, we have given them like variety. We can tell them that okay, these are the different topics, this is the list, and you can choose anything as per your choice, right? 4 will have, that will be a la carte system now, right? So 4 will have different selections. Now they will start discussion, right? They will start discussions. So you can see that now in this like generally I use this example many times with my students. So you can see that this is Bahubali, this is what Rocky Bhai from one recent movie, this is our own like what legend Mahendra Singh Dhoni, and then this is Sachin Bansal. Now if we see this 4 persons, 4 people, with why they were appreciated like anything, almost like industry was bankrupt. Film industry was bankrupt. That time Bahubali came and saved film industry, right? We know that. What was different in Bahubali? We can understand, right? There was a huge problem. There was a big problem. There was a ferocious, there was a cruel, like what what you can say villain was there, right? And the same thing is with what that KGF chapter 1, right? We know that Garuda or Bhallal Dev, right? They were very cruel, and their atrocities were like what unbearable, basically horrendous, right? So what they did with their like what society or like people around them, so that was depicted very nicely in those movies. And extreme cruelty, extreme diplomacy, politics, everything was like what there, right? So all things were there, and then audience also became part of that like what situation, and audience started like feeling or like everyone was like willing to have some kind of revolt against that situations, right? Even in Bahubali or in KGF. And when such rebel like hero comes basically, then that was appreciated very much, right? So there was very serious problem and there was a perfect solution to that problem, and that's why we appreciate it, right? So everything was new, setup was new, presentation was new, so people appreciated it. But the underline is what there was very difficult problem, and there was a promising solution to handle that problem, and that's why Bahubali or KGF was appreciated. Dhoni, we know that basically, like almost throughout his life, if we see his career, so earlier he used to come to bat at 6th or 7th position. You can understand 6th or 7th position means where like that position comes almost like 99% cases that situation comes when we are about to lose the match. But this fellow, this like legendary player, basically what he did, every one of us know basically. Even when he came at 7th or 8th position or 6th position, right? He played very well. And those matches we were about to lose, he batted very well and he helped us to win those matches. So that is amazing contribution of Dhoni. See, there is no one who scored 75 centuries at 7th position, basically. You know, coming to 7th position and securing or scoring 75 half centuries is not a small thing, basically. 75 half centuries at that place. Amazing contribution, right? So whenever there was a problem, he stood there as a better solution. And that's why he was appreciated. Otherwise, like Dhoni, there are many players in our team, right? But he is special. He's very special, not special. He's exceptional, right? Why? We know the reason, basically. Whenever, wherever there was a problem, he was there to solve that problem, right? Whenever, wherever there was a difficult situation, he was there with highest maturity required to handle that problem. That's why he was appreciated like anything. Sachin Bansal also, right? When we were like using Pune University local author books, right? That was an era, we know that those books were very costly, right? And generally people don't like reference books. Nobody like, even like we also don't like, because very complex and language like they use basically, and that readability, that like what convenience is not there, and that's why everything now shifted to what videos and gaming and animation, because see, the things should be very simple, then only people appreciate it, right? Anyway, so that time books were very like what, required things. People used to read books that time. Now since last 5 years, nobody reads books. That is really a serious problem. But anyway, this is what general facts I'm just sharing with you, and you know it's not new thing for you also. So people used to read books, and that time he started trading of those books, second-hand books, right? And then he like gradually developed that application into an e-commerce application, and then a business model, and he named it as Flipkart and then Myntra, right? We know that the success story of Sachin Bansal, right? Walmart now. So we know that basically. So whenever, wherever there was problem, in that locality, in like what our context, right? People came up and people worked on that problem, solved that problem, and derived great appreciation and profit also, right? So these are best examples of like what you can say them. These are heroes, right? They have earned a lot of significant profit, right? We understand that, we know that, right? The collection of Bahubali, KGF, appreciation and recognition for Mahendra Singh Dhoni, and the net worth of Mr. Sachin Bansal. We all knows about this, right? Okay, we all know about it. Anyway, so the most important thing and the essence of this discussion is what problems are very important. So when we give freedom to our students, and when we like what, give the choice to them, we need to provide them one more thing, and that is to understand our own problems, the ability to understand our own problems. We need to just tell them, you just go around, talk to different stakeholders. Society is one of the very like what biggest stakeholder. So talk to society and different like what compartments in society. Industry is one of the compartment, right? So talk to them, small scale, medium scale, startup, anything, right? Some disabled person, right? Some shopkeeper, some maid, right? Anything, in some like what, in a commutation, for example, or some passengers, for example, right? Anybody, kids, let us say, teachers. So there are so many people, so many compartments are there in society. So just ask them to interact with them and just try to understand their problems, real world problems. See, that is the basic difference between project and project based learning. In project, we just like close our eyes, contemplate on something, and we get something. Something is that problem statement, and we just solve that, we work on it, work on that problem statement, and we become happy. Or otherwise, we just go to Google, get some problem statement, solve that, and we become happy. But what is project based learning? Project based learning is not Googling something. Project based learning is not like what closing eyes and contemplating something. No, it's beyond that. What is project based learning? Project based learning is what? Interacting with real people to understand their real problem and to solve those real problems. That is called as project based learning. And it doesn't like signify, or it doesn't underline that, okay, you need to know big technologies and advanced technologies. No, all big solutions are based on very simple technologies, very simple technologies. Now, water purifier is like integral part of our life, and you know like what technology is used there, basically nothing, right? So it's very simple thing. It's very simple thing that way, right? Batteries, right? We know that. So there is long list anyway. I don't want to unnecessarily waste your time in that, but you can understand that, right? Every complex thing is simple. Every big thing is simple, right? Means the principle behind that, the fundamental principle behind any important, useful thing is very simple. It's very simple. Always it's very simple, right? So project-based learning will help us to understand real-world problems and to solve those real-world problems, right? So this is very important. Anyway, so this is about need assessment. So project-based learning means what? Interacting with stakeholders to understand their problems and offer realistic solutions, right? Realistic solution, contextual, I would say contextual, realistic and contextual, feasible solutions, right? So this is called as project-based learning, basically. Fine. Okay. So now this was about choice. Now, when it comes to creativity, see, when we provide them choice and that ability to like what understand real world problems, then naturally creativity comes. Creativity is such a thing, again, like we cannot like what inculcate, or we cannot like what rope in, or we cannot manufacture that thing, right? We cannot get creativity by training. For that, like what, we need to just allow anybody and everybody and leave it to his or her own imagination. That's it, right? When like we start imagining, then naturally that creativity comes. When we start referring many solutions, creativity comes. When we start interacting with many people, creativity comes, right? Cross domain, because see, technologies are there, problems are there, solutions are there. The only thing is what, basically cross sections are there. Some technology is already available in one domain and that is working very well, and in other domains some problems are there and they need some solution. So we need to just like what, change the domain, that's it, right? And we need to just like, we can just borrow those things and we can solve those problems, right? So things are already there, we need to just like apply them, that's it. And this is the way only, this is the simple algorithm for creativity. Creativity cannot be like what, you know, developed just by training. That creativity comes by experience only, good and bad experiences, right? And for getting good experiences, we need bad experiences, and for bad experiences we need to commit so many mistakes, right? The only thing is we should not repeat the mistakes, right? So bad experiences will give us good experiences, and good and bad experiences will help us to understand creativity or develop creativity among others. So simple examples of creativity, simple examples, right? So when we see so many solutions, so many things, even if we don't get these questions, automatically we start thinking about these three things: why, what, and how, right? Why is it required? And what is it basically, and why is it required, and how we need to implement this, or how can one implement this, and how it can help someone to solve some problem, right? So these questions, when we see so many things, naturally questions will come, and then we need to just like what, provide some answers to their questions, or otherwise we need to just leave them, they will find their own answers, right? Anyway, so this is what creativity, one of the simple example of creativity, how people like showcasing their creativity.
जब भी करण दिल्ली आता है तो हमारे घर ही ठहरता है ना, एकदम घर का मेंबर समझा, इतना एहसान किया, एक किडनी तो मांग रहे हैं उससे, तो होती है ना सबकी।
एहसान मतलब डिस्काउंट लो, वो भी फ्लैट 30% होटल बुकिंग्स पर, सिर्फ yatra.com पे।
So this is just simple yatra.com accommodation and advertisement, right? But how they systematically conveyed their message, you just see. You remember the plot, the expressions of that student or whatever, like person, right? So you remember everything. And now in subconscious mind, that yatra.com has also, now you have like what allowed. So now it has a place, it has an exclusive place in your memory now, right? So that is the thing basically. So this has become, or this is possible just because of creativity of that like what creator, whoever like what compiled this advertisement, right? So that is what basically a simple example of creativity. So again, the conclusion of this part is what creativity cannot be developed, right? It can be just, cannot be developments training, by training I mean, right? It can be like what developed by experience only, and for experience we need to interact with everyone and with everything basically, right? Okay, so then critical thinking. Now if creativity is there, now you can start thinking about so many solutions. So there are so many solutions now. Now which one to apply and how to choose a particular solution, right? How to be like what meaningful and relevant in all aspects, all situations. So for that, critical thinking is required. Critical thinking is all about decision making, right? Decision making. And again, decision making, critical thinking, we can't train. We cannot train basically. Like we cannot conduct a workshop and cannot like what demonstrate, okay, this is the situation, so that way you need to act like this and you need to get rid of those situations like this, like that. We can't, right? Again, this comes through experience, that's it, right? So critical thinking. So again, few simple examples of critical thinking, few simple aspects of critical thinking. So we are just going to discuss 4 basic aspects of critical thinking. So we will just quickly go through those 4 aspects. So one of the very simple aspect is asking right questions.
यहाँ जो भी आया है मेरे लिए भेंट लाया है, आपने कुछ नहीं दिया, जो मांगो वो देंगे आप। आपको माहिष्मती के सिंहासन पर विराजना है।
So fearlessly she is telling what she wants basically.
ये सिर्फ मेरी नहीं, समस्त प्रजा की कामना है, और कहते हैं प्रजा की कामना पूरी करना क्षत्रिय धर्म है, अपना धर्म निभाएं।
So whenever we define any problem statement, whenever we form a team, so our expectations should be very clear. Whether like it's a teacher or a student, right? If teacher is giving some problem statement or they jointly deciding some problem statement, so everything should be clear, right? Everything should be clear in the beginning and during like what implementation phases also. There can be multiple phases, right? So every time, right, we should always like careful about this very important aspect of critical thinking. Asking right question. If suppose something is going wrong, something is going well, we should be able to think, we should be able to ask why it is going well, why it is going wrong, right? So these are very important things. And if it is going well, okay, how to maintain it? And if it is going wrong, how to correct it? So this can be corrected, this can be understood by asking and answering right questions. So this is a very important aspect of critical questions. And when the discussion happens,
इस अहंकारी को बंदी बनाकर घुटनों पर छुपा दो।
आज्ञा राजमाता। देवसेना को किसी ने हाथ भी लगाया तो समझो बाहुबली की तलवार को हाथ लगा दिया।
now generally sometimes what happens, there are many solutions, right? Sometimes some things are correct, some things are not, right? Sometimes excuses are there, sometimes personal reasons are there, sometimes real problems are there. So in those all situations, we need to take right stand, right? And again, like what? So taking right stand is very important attribute of critical thinking, because there are many issues, many problems. We cannot take just simple problem, single problem, right? Now for a teacher, let us say teachers are very busy. Teachers are very busy, like what, people basically. So we know that, like, when we start like what applying for NIRF, then NBA comes. We are about to complete NBA, and NAC comes, right? Then teaching is there, right? Then what, like your exams are there, assessments are there, right? So many things are there, so many things are there. So there are so many problems, right? So to solve those problems, we need to take right stand. We need to decide what we want, right? And accordingly, we need to take a right stand. We can't be part of everything and every, like, means every problem and every solution. We need to decide whether we want to be part with problem or solution, right? So at least, like, we need to take stand and we need to decide and we need to stand by that, right? Okay. Then another aspect is decision making. So decision making is very important. Anyway, even though you don't understand it, but so there were so many people, right? There were so many people, and when Devsena fell down, there were so many people, right? And everyone was like thinking to help Devsena, but we know that who helped, right? And that's why he's hero. That's why he's called as hero, because he is always like apt in decision making, right? So decision making is very important thing. So we got something, we decided something, we took a stand, fine. But what about actions, right? So actions are very important. We cannot think about like 5-year plan. We live every day basically, right? Every minute, and that matters. Time is very important thing, and we need to take decisions, and that also on right time, right decisions, right time. So time is very important, and critical thinking, decision making is one of the very important aspect. And then the last, see, there are many, but 4 major components we have been discussing.
वो मिट्टी हिंदुस्तान की है और वो मयूरपंख मुगल सल्तनत का पेड़ जिसकी जड़ें हैं दिल्ली, और वो तीर मराठा साम्राज्य का। जड़ पे वार करो तो बड़े से बड़ा पेड़ भी गिर जाता है। कमाल है तुम्हारी सोच विश्व।
The clarity in thought and clarity in action is very important basically, because clarity in thought and clarity in action can help us to draw meaningful conclusion. And that's why we know that a 20-year-old boy become Peshwa of Maratha Samraj, right? Peshwa means, like, we can say that one of the very important prime minister, right? The king was Chhatrapati Shahu Maharaj, and he was his prime minister. We know that, right? A 20-year-old boy become Peshwa of a big Samraj basically, right? Kingdom. So empire basically. So why so many warriors were there, so many commanders were there, but why this honor he could get? Just because of clarity in his thought, clarity in his action, and other things, right? Other things means conclusions. He can draw meaningful conclusion. He is very clear about his beginning and his end basically. That is conclusion. Right, so we started with some problem statement. We started with so many things, right? We took right stand also. We are making correct decisions also. We should now very clear about our end also. End means deliverables. When we do that, that's it, right? Comfortably we can do that. So in team, we need to keep on discussing about this. So these 4 aspects are very important, and this is continuous process. It cannot, it doesn't mean that, okay, decision making happens once, conclusion happens once, right? Then taking stand happens once. No. Asking questions happen. No, this is continuous process, right? And in every meeting, every follow-up meeting, we need to discuss about this. Then collaborations, right? Collaboration. So teams are there. Always like you must have seen. Okay, first of all, we will just take one simple example. Generally, when we ask our students, okay, they work on some project, And we know that nowadays in COVID situation, there are many challenges. Hardware projects they can't work on. So most of the students are taking or working on software project. And whenever teacher asks, okay, what is individual contribution? So you or we get a very standard answer. Sir, madam, we work together. Who did this? Sir, we did together. Okay. Then whenever we ask, okay, what is your individual contribution? Sir, we four simultaneously did this. So all four were involved in this. I can't say that, okay, this is my contribution only. This is, everything is contribution of everyone of us, right? So that is general answer. So we misunderstood, and somehow we allowed them to go ahead with those misunderstanding. So we need to correct that understanding. See, teamwork, collaborations, right? And these are very different things, basically. Very different things, basically. Okay. So now teamwork, collaboration means what? Basically benefits. So we know that whenever we go to industry, so industry always sees basically why COEP gets everything, why IITs get everything, basically. Because they see potential there. Potential, I mean mutual benefits. They know that if suppose we provide something to COEP or something to IITs, so IIT can give them back something they can get from IIT. That's why they have their own departments like consultancy department, right? Research departments, big departments are there, right? Sponsored research and industrial consultancy is a big department in every IIT, and their turnover is more than the annual budget of IIT, basically, because they have set up a great team of skilled people, and they keep on solving industry problems and helping each other. So that's why collaboration means it cannot be one-sided. Collaboration is always two-sided, right? So you will help me when you will get something from me, and vice versa is also true, right? So always there should be, business may be a wrong word, but everyone should get something. Some deliverable, some outcome should be there, and if it is not there, then that team will not that teamwork will not last for good duration. It will immediately end up, right? So you can see here now, simple video is there. In slow motion, if you see what everyone is doing, you just see. Everyone is not doing the same work. Everyone has exclusive work. Everyone is doing certain exclusive work. You just see. There is no overlap of assignment or overlap of duties. Every individual is doing something unique, something different, right? But when it comes to our project, our student says that, okay, sir, we did this together, we worked together, and this is our joint contribution. So this is wrong, actually. This is wrong. Teamwork doesn't mean doing everything in team, doesn't mean that doing simultaneously and doing the same thing. And everyone is doing the same thing. That doesn't mean the teamwork. That doesn't mean the teamwork. Right? If everyone is doing the same work, then it is wastage of resources, wastage of whatever time, right? Resources, in resources everything comes, right? So energy and resources, right? So this is worst what management. So we should never go by that, right? Teamwork means what? Everyone is doing his own work or her own work. That's it. So being a guide or a team leader or a project leader, we should always ensure, if suppose some group is working on a problem statement, so some compartment should be made, some responsibility should be assigned, some division should be made, and every individual should be accountable for some work. And later on we can think about integration of that work, right? Okay. And communication. Communication is again very important thing. Communication means sometimes it happens project-based learning. The objective is what? Solving real-world problem. We always keep complaining that many startups are coming from Israel or United States or Germany, and generally we don't get such what happenings in our country, right? We always complain that we don't have good industry, we don't have Nobel laureates, we don't have desired number of patents, right? Patent rights. So we always keep complaining, right? Not you and me, entire country complains about that. But the reason is what, and the solution is what? Somehow solution is project-based learning. Solution is project-based learning, because the way Israeli education, Japanese education, or education in United States is, now somehow we are just trying to understand those good things and we are trying to implement in our context now. So why those people could do so many things? The reason is what? Reason is what? They interact with real people, real world problem they get, work on, right? They work on real world problem and they solve those real world problems. Because we are dealing with living people, we are dealing with live people, right? So those problems, if you solve, definitely, right? Business is there only, right? And wherever business is there, that IPR is there. And wherever IPR is there, monopoly is there, right? And demands are there basically. So somehow when we start working on or understanding real world problems, we can see the first phase is we will understand real world problem. Second phase is we will develop skills. It will take years, but we will develop skills, and then gradually we will get competency in that, proficiency in that, and then we can do what others are doing right now. So it's a process, basically. It's a process, and we are in the first phase of that process, and that's why our government and then the all educational policies, new education policy, and this is really a novel initiative our university is also taking, and in that AISSMS PMS colleges torchbearer, this is second activity they have conducted, and they very sincerely and with great focus they are doing this. So really great appreciation for the team at your institute. So basically, when it is possible, when everyone in the team is working with that dedication, then only it is possible, right? And for that, communication is very important too, because we think that, okay, anyway, we have 5 groups, and if one group is not working, what the loss? What is the loss? No, it's big loss actually. If one group is not working, if 2 groups are not working, that's a habit basically. That message will be like what, sent to next incoming batches, and then they will think that, okay, fine, even if we don't work, we get good grades, and if we get good grades, then why to unnecessarily solve some real world problem? Get some problem statement from internet, package it nicely, submit it, that's it, right? So for that like what, communication is very important, and for that we need to take few things very seriously, and among that communication is very important thing. Communication is very important thing. So again, just one small case is there. Communication here, I mean rewards and penalties. So just again, one small video is there. You just see any project group, this situation is there. There is one student who take up the responsibility and who will keep on investing significant time, his common sense, his intelligence, right? And he drive the entire project. In every project group, such situation is there. Then if you see, there is one more student, even if he is not expert, but his intentions are good, his efforts are good, right? Even though he is not skilled that much, but still he is complementing some or other way to the men, the leader one, right? And then another student, right? As per his wish, like he comes to college, right? If he want, he will work. Otherwise, he is like what? He's having many excuses, right? Mood swings and so many things are there, right? And there are few students like this also. So they will somehow unnecessarily create problems, and they will always see that everyone will be distracted. So in such situations, we need to take the charge of situation. And if we don't take the charge, then that will be very serious for us, because we are doing everything with a purpose, and our purpose is very higher, right? with a very higher purpose we are doing this. We want to ensure good learning for our students, right? And good returns for our institute, good returns for our society and country, right? So that's why we need to ensure it. We need to be sometime very straightforward. We are always, but sometimes like we just see that, okay, we understand, okay, he was having some problem, that problem, this problem, and we understand. And in a team, even if suppose 2-3 students are not working, we give them good grades, right? But it sends a wrong message. So somehow, if suppose some students are not working, it's not always about student. Even if suppose we are working in a team, like we always work on many industry and funding agency sponsored projects, right? Government sponsored projects. So in that team also we have many people, right? So sometimes some are good team player, they contribute significantly, and sometimes few are not, right? So we need to take charge of that situation. Otherwise, what will happen? It will spoil. It will spoil the project, then our reputation, and then our opportunities. So this is a very serious thing. So rewards and penalties are the only solution. Is the only solution to reinstitute all such disorders basically. So that is the only solution, and we should be very particular about these things. If we want to reinstitute everything and if we want to get everything in place, we need to take the charge of that situation. Okay, so that was about communication. Then the context. There should be context also. So I always use example of these 4 teachers, 4 professors. These are really stalwarts actually. Dr. Manjunath Mahadevappa, Dr. Jayanta Mukhopadhyay, Dr. Balkrishnan, they are from IIT Kharagpur and IIT Delhi. And then Dr. Himmatrao Bavaskar, he's medical practitioner. Dr. Himmatrao Bavaskar. The first 3 are engineers, but he is doctor basically, Dr. Himmatrao Bavaskar. So if you see sometime, whenever you get time, just go Google their names. So they worked on throughout their life, they work on very simple problems, but all problems are real world. All problems are real world. And that's why if you see their grants, they got great grants, huge amount of grants are there, huge appreciation is there, great publications are there. These all people have good transactions, transactions on their name. And Dr. Himmatrao Bavaskar, you just Google his profile. Dr. Himmatrao Bavaskar has 21 Lancet publications on his name. 21 Lancet publications, right? So he's the only Indian who has Lancet publication on his name, right? And so many Lancet publications, right? Lancet it's almost impossible actually. And for him, it's just very trivial thing. For him, it's very basic thing. So why could he do that basically? How could he achieve that? We need to really see their profiles. We need to learn their stories basically. And they are really inspiring stories. Dr. Manjunath Mahadevappa, throughout his life, he worked on assistive technologies, sometime for some hemiplegia, that is stroke survivors, sometime for visually impaired people, sometime for autism, and sometime for, let us say, some sign languages. So he worked on assistive technologies and rehabilitation engineering, and he suggested and developed so many meaningful solutions. And he got great appreciation all corners of the world, right? And great grants also. Dr. Jayanta Mukhopadhyay, so he was in charge of right now also Robocon at IIT Kharagpur, and he every time student used to solve some problem, he used to create a repository of that solutions, and finally he just integrated all solutions. So many meaningful small solutions for problems which Indian people faces in regular context basically. So many, telemedicine is one of the application, right? Sports related, so many solutions he have provided, right? So he worked on very small topics, but finally when he integrated them, it solved, those things could solve very complex problems, right? And that's why he also received so many grants and very good transactions on his name. Dr. Balkrishna and Dr. Manjunath Mahadevappa, they almost work in same area. And you just see IIT Delhi, IIT Kharagpur, how many grants and how many publications they have on their name. Then Dr. Bavaskar, he was working on, when he was posted in Chandrapur, that time there were many cases of scorpion bite, and that scorpions were very poisonous and people used to die. in a short span of time. And the same problem was like people at South Africa, they were also facing the same problem. And African scorpions are like very poisonous. Within an hour, that subject used to die, basically. That patient used to die in Africa. And there was a similar case in our country also, in Chandrapur also. So Dr. Himmatrao Bavaskar was anyway working on that problem actually, along with a student. And there was one drug actually that it was like Trazocine or something, BP and anesthesia related drug was there. So once when he was in his PHC, primary health center, so one scorpion bite case came, and everyone was aware that within an hour that patient will die. But somehow he has his own findings on that BP and anesthesia related drug. So he just took the consent of the family members of that patient and he administered that drug on that patient. And surprisingly, it worked very well. And he saved that patient. In an hour, he was about to die, that patient, but within half an hour, he saved his life. And then he just wrote one very small article on it, on that drug and that treatment. And Lancet immediately accepted it. For our papers, we get first rejection, then after 1-2 years, we get major revision, then again after 1 year, we get minor revision, and then again after 1 year, we get final acceptance. But for him, immediately he submitted and immediately he got final acceptance for Lancet, and not for just one publication, for 21 publications. Lancet, right? Legend actually, living legend. So 21 Lancet publication. You can appreciate, being teacher, you can appreciate what is significance of Lancet publication. So these are the people. So what they did basically, context is very important. So in India, we have like what always our Honorable Prime Minister says, one Sawaso like crore and Bharatvasi. So Sawaso Bharat Karod Vasi has so many problems. At least 25,000 problems we have. And we need to just only one problem of those 25,000 problems. And we need to just work on them. That's it. One problem can be solved with different solutions and can be continued means updated solutions and a continual improvement, right? For a long time. ECG, we know that, right? ECG, people are working on it since last 100 years. Still research is going on. EEG, one of the complex domain, right? We know that. So research work will never stop. It will continue always, right? So that way we need to just find problems related to like our surroundings, right? In our context, what is problem we need to identify and we need to just solve it. And those problems will be appreciated. Why Dr. Manjunath Mahadevappa or Dr. Balkrishnan or Dr. Jayanta Mukhopadhyay or Dr. Himmatrao Bavaskar are appreciated like anything? Because of context. They gave priority to their context, Indian context, our surrounding, our local context, right? So we should be also vocal for local, basically. So local problems, we need to understand them. Local means, it doesn't mean that Pune based problem. No, local means what? It starts from our house, basically, right? Our home, basically. We can see that like our mother may face many challenges, our servants or our maids may face many challenges, right? Then society may face many challenges, apartment or like wherever like you are living, basically. Teachers may face many challenges, right? So there are so many problems actually. We know that right now we are using this is Microsoft Team, I think, Zoom, Microsoft Team, Google Meet. So many like they just encashed the situation, right? So this way like we need to just come up with some real world problem, and that also related to our lives, daily lives, right? When we just get such problem and when we solve such problem, everything is like what? Immaterial then. And I mean immaterial means everything will come to you then, right? Generally in our culture it says that puja la pratishtha, right? So everything will come by default if we solve something real world, right? So very easily we can do that. Anyway, so that was about context. And then finally conversion. So conversion is what basically, see, whatever we are doing, it should see end. Till now with projects, when we used to work on project, now we switched to project-based learning. Till now we worked on projects. And with projects, what used to happen, what were reasoning of our students, whenever external examiners used to come, our student says that, okay, our solution was working till midnight, but somehow around 2 a.m. something happened and now it's not working. Or it was just like examination is at 9 a.m. let us say, so it stopped working at 8:55, just 5 minutes before the examination. So why that happens? Because it was just for the sake of passing that examination. We or they were doing it just for the sake of some grade, some evaluation, right? So somehow that component of like what ownership, belongingness was missing, and project-based learning has that component. And when we get that component, when we focus on that component, then our every work can give us meaningful outcomes. And there are many convergences. So generally we always see, like I always give example of coconut tree. In this tree there is nothing called waste. If you see husk, if you see its leaves, if you see its trunk, the fruit, actually the water, coconut water, everything, like you can make broom out of it, you can make fuel out of it, everything. So there is nothing called waste. So our project should be like this. So when we focus on our project with that intention of contribution and for solving real world problem, then there is 100% conversion. We also become, our every project will also become just like coconut tree. What it can give us? So product. So see, we always keep on and talking about entrepreneurship. How Israelis, Germans, and Japanese and Americans, they are coming up with so many startups, because their education system is like that, right? They keep on solving real world problems. They keep on developing some real world solutions, and they keep on pitching for funding to implement and to improvise those solutions. And because of that, what happens? They get good products, right? And they get good industries, and then they get good GDPs and living standards, quality of life, and so many things are there, right? So the origin is what in the education system. Origin is in what the root is, what our projects basically. So they can give everything with correctly supervised, with focused supervision, can get us so many things. So the first very important thing is what it may give us. It will give us a good prototype or a product directly. So saying just naming it as a product is a little difficult at this stage, but still it is a prototype, and by further improvements it can become a product. And if it is really solving real world problem, then you can patent it, you can design it, you can go for journal publication. If you think that it is not worth journal publication right now, okay, just take it for further development, write a proposal. There are many funding agencies. Nowadays, industry is also giving funding to many projects under CSR. Every industry has huge amount of fund actually. For them, it's very small, but for us, it is very big fund actually. Every industry has CSR, and for every industry, there is a mandate that they should support education system. So me, you, anybody, everyone can apply in the way we apply to AICTE AKI scheme or Department of Science and Technology or any Rajiv Gandhi Science and Technology Commission or any funding agency. Similarly, you can directly write one proposal to company, any company, every MNC, medium scale, small scale, everyone has that mandate. Everyone has CSR fund, and under that fund, you can just suggest them solution. It is not required that if they are working on, let us say, operating system, and you are working on some very basic solutions related to real world life or real life, basically, it doesn't matter. It doesn't matter, right? So there is no connection between CSR and their product of that company. It doesn't matter what solution you are working on. You need to just submit the solution or problem and tentative solution, and you need to just convince how society can be how the quality of life of society in general improve, basically how social change can be brought. You need to just justify that. So you can write a funding proposal also. If not, you can, if you don't want to do that, let us say, you can monetize it. You can just write a proof of concept. Pimpri Chinchwad College of Engineering is one of the best example. One teacher in mechanical engineering, he got a patent, and he got huge sum of like revenue based on that patent, right? So you can just write a proof of concept, you can write a patent, you can sell proof of concepts also. They will make it patent. And companies are very that way good actually. Even if they buy something from you, they will always mention your name. That way they are, for citations, for referencing, they are very good actually. For acknowledgement, they are very good. So you will get everything, name also, fame also, and that money also, right? Okay, then if you don't want to like what, let us say, convert it into proof of concept, try conference paper. There are many good conferences. On an average, every month throughout the year, minimum 500 conferences happens in our country. Minimum 500 conferences, right? So getting like what acceptance from one conference is, it's very simple. Of those 500 conferences, very easily you can get one conference publication. If not that also, then copyrights code is there. If you think that okay, it is not worth conference, it is nothing actually, it is good for nothing. It will never, there is nothing which is good for nothing, right? Everything has, you know, something meaningful in it. So you can take, you know, copyright for that code or for that like what matter, subject matter, whatever you explained there. So everything like, you know, will be meaningful in that sense then, and you will have so many things. You just see if one group is like any one thing out of each group, if you plan and you just see after 5 years what will happen. Minimum 5 groups are there in your like under you as major project, or any project like PBL is separate component that way. So 5 groups from each group, if you are getting any one component of these listed components, 1 year 10 groups, 5 years you can see 50 groups, and from each one component you are getting either publication, either patent, either POC, either copyright, either something or other, right? You just see after 5 years what will happen. The only thing is what we need to just change the mindset of learning. We need to reinstitute. That's it. Okay, so that is called as conversion. Okay, fine. Now then this is project management. So once the team is good, when the seed is good, yield is also good. So when team is good, when objectives are good, objectives are focused, when everything is planned, project management is just a formality. It's just a formality. Now we know that when we have Virat Kohli, when we have Rishabh Pant, when we have, let us say, you know, other good players in our team, Rohit and so many other players, good players, right? So this is what win is like bound to, like we are bound to win the tournaments, right? Because we have very good combination, good blend actually. So managing good players may be difficult, right? But recipe is perfect basically. Now we have good team. We have good team means good results are by default, good results will be there, right? Good results are bound to come basically. But still, to get good result, we need to answer some questions. We need to get answers of those questions. So these are very important things basically, and we should always like focus on those questions. So project management is all about basically few questions, maybe five questions. The first question is, what problem are you solving? We should ask ourselves what problem we are working on basically, and we should always remind ourselves like what problem we are solving, right? What are the, asking this question means what, understanding what are requirements of this problem, what skill set is required to solve this problem, right? And then what will be the deliverables. So we need to keep on asking us every time, like what nowadays that agile, and then that so many DevOps and so many like what Scrum and so many like what project management tools and techniques are there basically, right? Anyway, right, those techniques are there and those are very excellent, and you will be learning. I have seen in the TRIZ is also there, I think, so you will be learning so many things basically. But the very basic fundamental thing is what, just like understand if you want to implement this solution, what are the requirements, what are the deliverables, what are the skills required. Accordingly, you can form your team. Accordingly, you can form or like plan your reviews, and every review you can keep on asking. You won't be deviated, you won't be distracted if you are always on this question. Then the next is what, how are you going to solve this problem? So how are you going to solve this problem? Is there any plan for it? Or you are just thinking that, okay, 4 very intelligent people I have hired, or I have 4 very intelligent students in my group, so they will do by their own and I need not intervene, or I need not like play any role. No, it's not like that. We need to make plan. So we need to make a good plan, basically. We need to ensure those members are getting good resources, right? We need to make a schedule also. We may call it as review schedule, right? So, and we need to have a process also. We need to have a template, basically. Okay, fine, right? Okay, after 15 days you are meeting. So in 15 days you need to do this, right? We need to understand, we need to plan some realistic timelines. If suppose people are already busy and we are just making some unrealistic deliverable plan, then it won't work. So that's why communication is very important within the team. So accordingly, we need to make a schedule. Accordingly, we need to allot resources, right? Sometimes investment is very important component in it, but nowadays it is not a big issue. Basically, everyone is willing to invest, starting from student to all institutes, right? Everyone has good resources nowadays. And then basically process. So simple like what in our institute, right? I have two mentors, Dr. Rajesh Jalnikar sir and Dr. Swati Shreskar madam. So I have seen both of them use simple tool, Excel sheet. And throughout, like in a sense, last 10-15 years, I am saying based on Excel sheet, everything happens on Excel sheet. Very comfortably, no automation, nothing fancy like things required. With simple Excel sheet, there's two like experts manage everything, starting from projects to our all like what big plans basically. So it's very simple that way, but there is a process. Actually there is a process. VIT like is one of the is the only institute in this like what in a segment having A++ grade. Almost like all programs are like NBA accredited and have scored good marks, right? NIRF ranking this time it is 122, right? So this is what a very continual effort is there and systematic plan is there basically. So process is required basically. And then just as I told you, the plan is what basically the thing is the same thing, like what plan like we are having for that. So this way we need to plan everything, right? How are you going to solve this problem? Answer is plan. And what is plan? So how much work is there? How that work need to be divided? Then what resources are available? How resources should be allotted? What should be scheduled for like what sub completions or some like what you can say divide into multiple tasks, and how much time should be required for that realistic analysis has to be carried out. And then the process for review. So those basic things we need to do. Okay, then after that one very important component is there, and that is called as how will you know when you are done? Does it mean that some LED is now glowing or some output is generating or some voice message is coming, some detection, some recognition is happening? What is it basically? What is called as completion of work, right? So what is it? When we will understand that yes, we are done now, right? So some quantifiable or we say it, we call it as KPIs, right? KPI is very like big term anyway, but some quantifiable measurements we need to define. And when such quantification is very important. When we quantify everything, then comfortably we can achieve everything. So we need to quantify the things. So I learned this quantification and measurement from these two like experts just I mentioned. So basically quantifiable measurements we need to define, and we need to keep checking throughout our implementation. Every meeting should be like based on those quantified measurable parameters. And when we do that, comfortably we can we can achieve what we planned initially. So productivity, if you want to increase for anything, productivity in terms of let us say project quality, publications, patents, copyrights, designs, everything, right? Solving real world problems, getting appreciation, getting funded project, funding, right? Getting like what good research project. So this is what outcome of learning based project based learning, right? So this is called productivity also. So and that comes through just a simple discipline. And then the last question is how well did the project go? So generally we neglect about this. Now when everything is completed, we should take review, final review. We should think about, we should do brainstorming. If suppose our project is completed on time, in time, why could we achieve it? Okay, because of this 4 or 5 things we could achieve it, highlight them and repeat them, right? Then if suppose something went wrong, so why those things like go or went wrong. Basically, we need to analyze them, what corrective actions are required, how the solution can be improvised, how we can make it better. So that way we need to keep on thinking. We know that Google, after every 6 months, they keep on launching some new feature. Neither you nor me tell them to add that feature, right? Almost like what 75-80% part of the world is using Google Classroom for conducting classes, right? And every day, after every semester, they are adding one or other new feature. Basically, that's why we never leave Google, right? So we are always like loyal customers of Google, basically. Google, YouTube, right? Because they are adding value. They are adding value, and they every time keep on checking. Every time they are keep on checking, basically, and keep on thinking on like what went correct, what went wrong, analyze, correct. That's it, right? So this is all about project management. Project management means this. There are many questions, many answers, but these are the major questions. If we could understand those questions and if we could understand answers of those questions, project management is just a general thing. It's just the way we wake up and come to office. Similarly, management will also happen. Project management will also happen, right? So this is about our session, and lastly, takeaway. So for this project-based learning or whatever deliverables we spoke about, whatever productivity we spoke about, this is entirely depends on our students. Entirely depends on our students. And basically, I always try to convey this message to my all fellow colleagues. See, nowadays, every student will be getting minimum package of 4 lakh rupees per annum. And such minimum 1,000 students are there in our college. When they are in second year, third year, final year, they generally don't contribute much. But the moment they join industry, we see their success. They get many patents, they get great packages, they do wonders. But somehow, I don't know like what is the problem is, but somehow either they don't contribute or we don't utilize them. But at least from now we can see the thing actually as it is, and we can see that 1,000 into 4 lakh package. So this many resources, the resources worth this much money, this much amount, this much revenue are with us right now. If a company can produce, or if a company can make great profit after some investment, why can't we get what deliverables we are expecting? May it be publication, may it be some good infrastructure for our country, may it be like what solution to our problems, problems in our context, basically. So why can't we solve those problems? Very easily we can do that. We can do that, right? Very easily we can do that, basically. The only thing is what we need to understand the student capital, and we need to utilize the student capital, and it's very easily possible. And now we have got an official tool in our hand, that is what basically project-based learning. Project-based learning can change our profile. Project-based learning can change students' profile. PBL can change our placement profile. PBL can change our entrepreneurship profile. PBL can change net revenue of our industries, and PBL can change like perception about our country. So PBL has great potential. So just one small request is that please take it seriously. Whenever you allot any project to any group, so please be a party to it and see whether it is based on some requirement analysis, right? And even though, see, everyone is not like what, everyone is not like, all are not same, basically. Everyone has got some separate skills, basically. But for solving real world problems, intelligence is different thing, basically. Talent is very altogether different thing, and defining talent is very complex job, actually. But for solving any problem, only motivation is required. And if suppose along with that, if talent is there, then what to speak about that combination, right? But if you see till now, history, based on history, motivation always beat talent, right? So it doesn't matter whether it is IIT or it is COEP or any other college, BIT or any other college, AIM, SSMS, PMS, or any other college in our country. That really doesn't matter. That really doesn't matter, right? Irrespective of any infrastructure, irrespective of like what students we get, comfortably we can implement it, right? Because here motivation is the key factor, and we need to just like follow those 7 C's and some project-based like what evaluations basically means, management related evaluation, project based management related 5-6 evaluations we need to carry out. That's it. Based on that, if we are like very sincerely do this, then our profile after 5 years will be completely different. There is no need. Generally we think that only research students can change our profile. Our profile means research profile. No, it's not like that. We know that it is not a secret. Basically we know that, you know, BTech, MTech and PhD, right? Right now good implementation of PBL can change the scene. Basically that canvas, like we know that basically how who are BTech, who are MTech and who are doctorates, right? So everyone has their like strengths and like what and capacity, but somehow like what one just message I want to like what just pass on. See, it is not MTech or PhD or BTech add value in our research profile, right? It is our mindset. It is our mindset. And if we have a mindset of learning, comfortably we can have a great profile for everyone, whoever is part of it and wherever we are living, right? So everyone's profile can be changed. So problem solving, project-based learning is very important. Thank you so much. If you have any question, please let me know. So with this, I would like to conclude this session here. Yes, so if you have any question.
Yes, sir. I request all the participants, if you are having any doubt, you can ask the questions to Shripad Bhatlavande, sir. The forum is open for all of you.
Can they unmute themselves, madam?
Yes, sir. Yes, sir. They only cannot write down anything in the chat box, but they can unmute and they can ask the questions. I request all the participants, if you are having any questions, please proceed.
Yes, ma'am. Hello.
Yes, ma'am, you can proceed.
Hello, participant. If you have any question, please unmute and ask.
Okay, it seems.
Sir, I am having one question. Hello.
Yes.
Sir, regarding the ethics and also, as per the SPQ curriculum, they have given some weightage for ethics.
Yes.
So while writing their, you can say the project PBL report, so what kind of things, whether this will go for the ethics, means exactly what is expected in the report writing related with ethics?
Basically, in ethics, they should understand, like, you know, the basic principles of research whenever we are referring something, right? So it should not see, now, for example, we are developing some solution, let us say. So general step is what we do literature review and we try to find out some research gaps, and then somehow like what we try to position our solution as one of the best solution. We say that okay, that author lacks this, that solution lack that, but somehow our solution is one of the best solutions. So while doing that, while comparison, we should ensure in a dignified manner we should compare those solutions. We should not hurt their sentiments, right? That is one of the aspect. If suppose we are referring someone's work, so while referring we should give due citation, and it should not be like that we are taking everything and we are just adding like what just one like in a morsel we are adding, and as it is we are taking others work. So it should not happen. And in a team also, now there are 4 members. We should not say that, okay, there is no like, wisdom in just saying, okay, we all did simultaneously. This is our joint effort. No, individual contributions are there. When we say that, okay, we all done this or we all completed this, so somehow we are just like what, undermining efforts of contributions of one individual, right? If suppose someone has really contributed well, so he should be reciprocated accordingly. Right? So wherever like whoever deserves, we should appreciate. We should give due citation references, right? And this way, like what these basic practices are there. So what efforts we are taking, so we can just document there, or what they have done to ensure all those things, so they can document there.
Okay, and one more thing they have mentioned in the SPQ syllabus, that is legal aspects.
Okay.
So again, can you please highlight something on this?
So legal aspect is what? Yes. Okay. See, basically what happens now, there are many incidences. Just one example. Once, like, there was a group actually, and we were just interacting with that group, and they said that, okay, their team has like worked very well, very nicely, and their problem statement was very good. They have written one very good manuscript, and they said now they are submitting this manuscript to some journal. So they were very happy, and their work was also good as per their like what, descriptions. So they were very happy for that, and then they said, okay, they are submitting their work, and they submitted their work around 2 p.m. around 2:15 p.m. they submitted their work, and then around 9:30 I received one call from them, and they said, a great news is there. So, and then he started sharing that great news. He said his paper got accepted and already online now. It's already published now. It's already published. You just imagine that group submitted their paper at 2:15 p.m. and they got published their work at 9 p.m. or 9:30 p.m. around, right? There was no review, no peer review. It was just published directly. Nobody was there to cross-check what plagiarism was there, and whether due citation referencing is there or not, whether originality is there or not. Somebody just said, okay, it is original, it is like what, authentic, and it is a new thing, right? Somebody believed that, somebody published that, and now it is in public domain. If suppose somehow by any way, if suppose some infringement is there, you just imagine what consequences will be there. If suppose some infringement is there, then they can sue that group. So that is very like, serious issues. So whenever we don't follow ethics in material like what setup, whenever we don't follow ethics, whenever we don't like, cite them, whenever we don't provide due credit to them, then legal action is bound to come to us, right? So that is legal aspect. So generally we should always refrain from all those like, such practices, malpractices, I would say. Yes. And we should make aware about our student, because generally what happens, if suppose somebody is getting publication, one group has got one publication, one paper, one patent, one something, right? So other group get tempted, and then they may like, tend to submit something in hurry, and in that hurry a lifelong worry may come. So we should take care.
Okay. File, madam.
Yes, sir.
Yes, sir.
Patlaonde, sir,
Yes.
indeed it was a great motivating session, and you have covered all the aspects, ethics, then moral values, project management, and also you have given very good clue how to identify the real life problem, and you have given example of the great people who have worked for the society. So definitely it's a motivating session for all the teachers, and how teacher also should use moral and the ethics values for the betterment of the society. So definitely, it will help everyone to implement project-based learning. And in spite of your busy schedule, so you have spared your valuable time, and every time you are supporting our department and the college. So from my bottom of heart, I'm really very much thankful to you.
Thank you, sir. Thank you, sir. Right. Thank you, sir. Thank you
While
so
madam-
much for this opportunity. Yes.
Yes,
So,
yes, sir.
Bhalke sir.
Thank you so
with your-
much, sir.
Yes, ma'am.
Yes. Yes.
Yes. Thank you,
so
sir.
much, sir.
Thank you, madam.
So the videos that you have shown on various aspects of ethics are really very nice. From that, we able to understand the philosophy of morals in a very easy way. Also, the way you relate few videos from movies with the features such as how to take the right decision, meaningful conclusion, how to take a right stand, etc. Those are really very appreciable, and it simply shows your out-of-box way of teaching. Once again, thank you so much, sir, for your valuable guidance and the precious time. Now, with the permission of the coordinator of the event, Nitin Mawe, sir, I would like to declare the end of today's session.
Right. Yes.
Thank
So
you.
thank you,
very much.
Bhalke sir, Mavale sir, madam, and Bormane sir.
Thank you so
Thank you
much.
so much. Yes.
Thank you.
Thank you, sir.
So
All
Bhalke
participants are
sir, Bhalke
informed.
sir, may I leave the meeting? Yes,
Yes,
Bhalke sir. Huh? Right. Okay.
Yes. All participants are informed to appear for quiz. Link is available in the chat box and on the WhatsApp group also. Thank you, everyone. Have a nice day ahead.
Yes, sir, I can leave the meeting.
I would like to repeat it again. All the participants are informed to appear for the quiz. Link is available in the chat box and on the WhatsApp group also. Thank you, everyone.